Can we start, sir? Can we start, sir?
Madam, we can start. Your audio is too low. We can start, madam.
Morning, everyone. I welcome you for the day 4 of the FTP. I'm Swati, Assistant Professor, Department of ECE, Bangalore Institute of Technology, Bangalore. We live and die by our communication system, successes and failures. So it is with special excitement that I'm pleased to welcome Dr. Pandian to the day 4 morning session. I welcome you, sir.
Thank you, madam.
Dr. P.S. Pandian completed his BE in Electronics and Communication Engineering from University of Madras, ME in Medical Electronics from Anna University, and PhD in Biomedical Engineering from IIT Madras. He has 25 plus years experience as scientist in Defense Research and Development Organization DRDO. Currently serving as Director Technology in the areas of electronic warfare. Areas of interest includes biomedical instrumentation, telemedicine, nanotechnology, MEMS, biomedical signal processing, image processing, optical imaging, and microelectronics. He has published about 50 papers in various reputed journals and conferences at about national and international levels, and he has 2 patents to its credit. He is a fellow IETE life member, BMESI, ISSS, AOC, and IPMA. He is a reviewer for various reputed national and international journals. He has received Lab Scientist of the Year Award in 2002, DRDO Young Scientist Award in the year 2004, National Academy of Medical Science Award in 2008. I'm welcome you, sir.
Thank you, madam.
Okay. Over to you, sir. We can start the presentation, sir.
Yes, madam. Madam, you are able to see the screen, madam, the presentation?
Yes, sir. Yes, sir. Yes, sir.
Yes, madam. Good morning, madam, and good morning to all the participants. Thank you very much for the introduction, and thank you very much, madam, for inviting me for this guest lecture. So the topic I had chosen is microelectronics and biomedical applications. I will focus on two particular areas. One is Internet of Things and then wearable health monitoring systems. These two are very important topics in the current scenario. And if you see that most of your devices are merging towards the wearable health monitoring system and they are leading towards the Internet of Things. So I'll cover them with an focus to these particular areas. And then I will start the lecture with basically bringing out what is the difference between engineering and science. Basically, most of you are engineers, and then basically you need to know what is the difference between an engineer and a scientist. So scientists basically try to create new knowledge and how things are going to work, whereas engineers are going to understand well the tools, the science and the mathematics, and they provide and utilize them to solve any problems which is of any importance for the public and for gaining economical gains. So that is a basic difference you should know. Basically, most of your applications, what you develop, if you want to commercialize them, the most important application will be your medical sciences. So it will lead into the biomedical applications. So any engineering applications or any mechanical, electronics or computer science, if you have to make a huge return on investment, if you can find an application related to biomedical engineering, then you will see that you will be getting a huge return on investment. So basically, biomedical engineering is an application of engineering principles and design concepts in the field of medicine and biology. The biomedical engineering provides electrical, electronic, electro-optics, and computer engineering support to both clinical and biomedical applications. And biomedical engineering as such will see that the field of healthcare, it is going to be used for diagnosis, monitoring, and for therapeutic applications. So what are the disciplines of this biomedical engineering? You can see that there are various disciplines, right from imaging to biomechanics to materials to sensors, instrumentation, rehabilitation engineering, analysis, biomaterials, instrumentation. There are so many areas, and you can see that it leads into various applications based on the potential applications what are likely to be. And there are various sub-disciplines in that. For example, biochemical engineering, bioelectrical, biomechanical, biomems, nanomedicine, telemedicine. These are some of the subsystems of the biomedical engineering. So who are these biomedical engineers? Basically, biomedical engineers are engineers for life. They don't have any retirement. Basically, they work in the field of biomedical engineering and they do service to humans. So service to humans is like doing service to God. So biomedical engineering has a wide range of applications and it has got true potential, and the potential is unlimited, and it is left to you to think. Basically, it's typically a blue sky research. So this field is highly interdisciplinary and you need to do a number of collaborative research, and you should have collaborations with various departments. Then you will see that you will come up with a better product. So if you align from basic knowledge with electronics or mechanical or any computer science knowledge, and then you align towards the biomedical applications, you will see that you will have a good career prospects. Career prospects will be like excellent job prospects both within the country and abroad. And you will see that the job forecast will be about 70 to 75% growth in the next 10 years. You can see that getting a job is also quite easy. And then it is being a biomedical profession, you will see that return on investment will be very, very high. So basically how these areas started, the biomedical engineering, you will see that though a lot of devices are coming up, a lot of inventions are happening, you will see that the immediate applications, typically if you take X-ray as such, X-rays when they were invented, they immediately started using in the hospitals for imaging, and you had seen that they had been doing very well. If you had seen that when radio was invented, some of the predictions by the earlier scientists was that they were saying that radio does not have future, but you can see that now radio is being used everywhere. The without the RF, you will not see any devices being available. You can see that even your house devices, even your mobile communications, all are well connected, and your life moves on with the radio communications. And also when the aircrafts, before the invention of the aircrafts, people were under the impression that heavier than air, they cannot make any objects to fly. But now you can see that the aircrafts have been invented. There are so many things which fly, the missiles fly, helicopters. You can see that many machines have been invented and it is possible to make them to fly and non-stop for longer durations. Also, when X-rays were invented, people were under the impression that it's an hoax. And when Ranjan invented in 1895, people were under the impression that it's a fake thing and people are not giving a correct information. But you can see that within few months after the invention, people had used in the hospitals for imaging for any skeletal disorders, and then they have been using very widely. And now you can see that n number of devices have come up, and then X-rays are very extensively used for imaging applications. So basically, what are the public health challenges people face is due to the acute to chronic conditions of the health conditions of the persons. One is the aging population. Because of the good health care, you will see that people's age expectancy has increased. And as the age is increased, you know that the health issues are going to be coming up, and then people need good medical health care. And also we should ensure that equal treatment is given to everyone. There is a lot of health disparities among the rich and the poor. Next is this emerging diseases. And you must have heard about the SARS, which had come quite some time back, maybe about 15 years back it had come. But due to the non-availability of this much communication things, it was not known to people. And the subsequent variants of this SARS is the COVID, and it has affected very much. You know that last 3 years we have been suffering due to this COVID. And these kind of diseases don't have any kind of a treatment, like Ebola or the fruit bat diseases. They don't have proper treatments, and then you don't have time to treat them also. These kind of diseases are emerging, and you need to ensure that proper medication is going to be discovered within a very short time. Next is the biodefense. The NBC, nuclear, biological and chemical warfare, is one of the biggest threat due to the political issues, geopolitical issues. And when these kind of an NBC warfare is taking up, how do you protect yourself, your country, and your fellow people? So these are some of the things the public health challenges are going to pose to you. So basically, what is that is the challenges we are going to face. Basically, it is the interdisciplinary research I told you. Most of the interdisciplinary researchers have to come from the academic institutions, and it is not possible for an individual to do an investigation and bring out. So it is going to be departmental, interdepartmental. But whereas most of the institutions, they work in isolation, which is not good for the biomedical research as such. And also it takes time. It is not a simple thing. You must have seen that when the COVID came, the first vaccination started coming only after 1 year of the COVID was detected. And also most of the students nowadays have lack of interest in the scientific researches. We should motivate them and then bring them into the main core of these researches. Students should be made to understand that the money is not just the only factor. The scientific community also should be built up, and we should encourage them to do research and take up newer areas. And also you can see that biomedical research is not that we can make a product within time, because there are a lot of qualifications in terms of medical certification, device certification, and then you need to do the clinical validation before you launch the product. So it takes time, and since we are going to involve in human, and this human experimentation is not just easily possible, we need to ensure that proper protocols are going to be followed. So basically what is happening in the current scenario is conventionally the patient goes to the hospital, he goes to the clinical setup, and then he gets his blood samples or imaging or any kind of an samples he is going to give, and then the doctor is going to diagnose, and then he is going to give a treatment to that. So this is what we are not looking at. We are looking at an extended versions where persons can be mobile, he can be moving around, and once he goes, we are looking into a concept where he goes to only one place where all the diagnosis has to be taken, and then it has to going to be treated. So basically we are looking at a kind of a concept where a person can be easily monitored continuously throughout, and then he is going to be diagnosed while he performs his routine activity. So basically, how are these possible? These are possible due to the advancement in technologies. Technologies in terms of what all? What all in the technologies, if you see, we see the sensors and materials that we call it as smart sensors, and the electromechanical systems, that is the MEMS. Next is the nanotechnology, The communication technologies as such, you must have seen the wireless technologies, the 4G, the 5G, the Bluetooth variants, Zigbee, the Wi-Fi communication systems for short distance communication. The next is the VLSI technology, both for analog and digital, has come up in a very big way. You can see that a lot of FPGAs have come up, and because of that, it is possible to do miniaturization. We can make low power devices, and then we can have a devices in mass production, and then you can reduce the cost. You can see that n number of devices and all your mobile phones are becoming cheap because of this VLSI technologies. Next is the high speed processing, and the processors are available. They are capable of catering for high speed processing, and we also seen that because of this high speed processing, you can take immediate decisions and you can process your noisy signals or images, and then you can produce them immediately for the doctors to treat them. Now I was mentioning you that the conventional method is the method where we go to the hospital and then we try to take samples, move to various departments, and then meet every doctors and then try to do. But that is not what we are looking at. We are looking at point of care health diagnostics, meaning that the patient is at one place and all the analysis is going to happen at the patient site itself. We are not likely to move, and we are going to use these technologies, and then we are likely to have the diagnosis and then the treatment happening at a very shorter time. That is what we are looking at in the point of care diagnosis. So this point of care diagnosis is what is going to be the future. So what are the devices which are going to come? That is, the devices are going to be integrated. They are going to use technologies like MEMS, Nano. Like for example, we are talking in terms of lab on a chip or a pharmacy on a chip, where only a few microliters of samples of blood or urine is only going to be drawn, or the devices are just going to be placed onto the skin surfaces and micro needles are going to be inserted onto the skin surface, and it is going to draw very microliters of samples, and you are going to have multiple analysis being carried out, and these devices are immediately going to produce what is the diagnosis of your samples. So that is what we are looking at. That is what the future of healthcare is looking at. So MEMS and Nano is going to play a major role in that. So you know that many of you might have studied about what is MEMS and nanotechnology. Basically, what are the advantages we are going to gain by use of this MEMS and nanotechnology? Basically, the sample volume is going to be very, very small. We are not going to draw a huge amount of samples of blood or urine, which is going to be very painful for a person. And these devices are going to be miniaturized, and they are going to be consumable types. It is one-time use and then it is going to be thrown off. And they are going to use miniaturized batteries. Power consumption is going to be very less. It is going to be less invasive, so it is going to be less painful. And we will be building in larger number of systems on a single chip. And then you will see that these devices are going to be very, very cheap because of the batch processing. We are going to have these devices being manufactured in a very huge quantity. Also, this MEMS and Nano, the advantage is we are not going to have any different technology for making these devices. The existing IC technologies which are being used for fabrication with additional equipments are only going to be used for fabricating this MEMS and Nano devices. And more silicon as such is more commonly used in MEMS devices. So you know that silicon is highly biocompatible and you can use them with the body tissues without any problems. Whereas nanotechnology, the biocompatibility studies are still going on. We need to be very careful because nanomaterials are as such are not biocompatible. Studies are still going on. So can these MEMS devices can replace the existing medical devices? So you can see that definitely the answer is yes, because these MEMS devices are highly miniaturized, and you will see that the cost is very, very low when compared to the conventional devices which are used. Typically, you can take an example of a blood pressure monitor, which was, you must have seen the conventional Spigmo manometer, which was only available in the hospitals and people can't afford that. And the Spigmo manometer is highly accurate, but it needs expertise to use those devices. And also the Spigmo manometer, the pressure sensor used in the Spigmo manometer is the mercury manometer. It is not compatible, biocompatible in the sense that it is not environmental friendly. In case you dispose them just like that, it is not good. It is not a good practice. It has to be disposed in a proper manner. Then the inventor of this MEMS pressure sensors immediately found application in the blood pressure sensors, both for invasive and non-invasive applications. They are very, very cheap. They are available at very few dollar prices, and they are mass produced, and they have replaced all the conventional blood pressure monitors. And you can see that in at your house also you can afford for a blood pressure monitor at a rate of even 1,000 rupees. It's available, and they are highly accurate. They have been well calibrated, and you can see that the MEMS devices is highly promising, and you can see that these devices are quite useful for your routine health monitoring. You can see that when these MEMS devices started coming up, somewhere in the year 2000 onwards, the MEMS researches have been going on in various areas. Somewhere in 2006, there have been a lot of flooding of all these MEMS-based devices. You can see that in the computer industry, there were about 26% use of these MEMS devices, especially in the inkjet printers. The printer heads were based on the MEMS devices. And in communication technologies, about 21% was used. And in automotive industry, especially for the pressure sensor in the car airbag activation systems. This car airbag activation system was based on the pressure sensors installed throughout the car on the outer surfaces when there is an impact being detected, and the airbag is to get activated. These pressure sensors were expensive and in turn leading to the higher cost of the cars. Now these pressure sensors are available at a very cheap price, and you can see that the automotive industry, most of the cars are using these MEMS-based pressure sensors. Industrial applications were about 22%. You can see that consumer electronics had about 3%. Medical devices had about 11% of usage. And subsequently, you can see now we are in the year 2022. You can see progressively how these MEMS devices have flooded the market. You can see the healthcare industry has taken almost the major role. You can see in the year 2022, the major consumers is the healthcare industry. The consumer electronics is also using, and you can see that the healthcare industry is growing up in a very big way as a largest user of the MEMS-based devices. So you can see that the return on investment on all these devices is also very, very high. And you can see now, other than the healthcare industries, the RF MEMS, because most of your mobile communications is going to use these RF devices, especially for the antenna, and then the other sensors which are going to be built in, especially your accelerometer, gyros. There are so many sensors built in into your mobile phones. And for the RF, that is a major portion which is going to be the basic unit for your communication systems. So the RF front end, the processing, everything is built in into your mobile phones. You can see the RF MEMS is occupying a major industrial contributions. The reason being that the consumers of these mobile phones is very, very huge. And you can see that in a particular house in a country like India or China, minimum there must be 2 to 5 phones per house being commonly used, and everyone at least has got one phone. And in cities and all, you might see that they might have minimum 2+ phones. So you can see that the consumer is going to have a huge output, and then the return on investment on these MEMS devices for RF and medical is going to be very, very high. So what are the challenges you will face when you are going to design and MEMS-based devices? One is the size reduction, and you need to build in more intelligence. Then next is a competitive price. When you are going to do research in these MEMS devices, what is the competitiveness you can bring in? Because you also should know what is the competition in the market before you make a device in the market, and what all the new applications you can target. Suppose if the market is flooded with a number of pressure sensors, now, if you start a new research bringing in a conventional pressure sensor, you will not be able to compete, and there won't be anyone to take up your device. So you should see that, suppose if you are making an accelerometer, suppose there is an accelerometer meant for a triaxial accelerometer, which can go up to only plus or minus 16G. You can think and target an application where there may be an applications up to plus or minus 24G. You can try to design a device. So that is how you should think about not a conventional device. One more important thing what you should think about this MEMS is MEMS takes time to come into the market as a product. The average R&D time is about 10 years. The product evolution takes about 8 years. The costing is also going to be very, very high. And typically from R&D to commercialization of a product, it takes minimum about 27 years is the think what people have predicted. But now with the technological advancements, this can be reduced. And you can see that from R&D to the commercialization of the product, when the pressure sensors were there somewhere in the 1960s, they have been doing a lot of R&D on these pressure sensors for the miniaturization and cost reduction. You can see that it takes a lot of time. And you can see for the other devices also, it takes a lot of time. The RF MEMS have taken very shorter durations. You can see that it takes a lot of time for your devices to come into the market. Especially for the BioMEMS, you will have to see that how you will be doing the clinical validation as well. Some of the typical applications of these MEMS devices are typically one is a lab on a pill. So basically you wanted to do an imaging of your endoscope. You want to use an endoscope to see the intestine and other places, or typically look into the colon cancer for an early diagnosis. The conventional methods are very painful and it is not very comfortable for the person to do the imaging. So what they have done is they have made a smaller capsules in the form of a pill where there is an digital camera in the form of a CMOS technology, and there is a smaller light source, there is a battery, there is a wireless transmitter, and there are sensors integrated. So the person can digest this, they can take this pill, and then the pill moves around, and you can see that the images are going to be transmitted in real time, and then the images are taken and analyzed, then the pill is going to be secreted out. And this is very easy, and then it can be tried out multiple times also. So this is a very easy process, very cheap, and it's a disposable pill. So this is what people are looking at. And there are some other the MEMS based ultrasonic cutting tools are available where you can, there is a piezoelectric material, they can be used to flush out the fluid and debris while cutting also, and they can be used to cut down the dry or tough tissues which are being hardened onto the patient's skin surfaces, or it can be used for the cataract treatment as well. And also there are MEMS based skin resurfacing tools. They have been conventional methods are not quite useful, and you can see that these resurfacing tools are very smaller in size. They are about 50 microns. They are fabricated using the MEMS based technology on a silicon surface, and you can see that they can be used as an abrasive tool to remove the dead skin layers on the surface of the skin, and then you can see that they can be less painful for the person when you are going to use them also. Also, there are a number of micro and nano robots being commonly used. These robots are highly scaled and they are micro or nano in size. They are meant for using drug delivery or even eliminating some kind of health problems. So basically, if you wanted to remove some unwanted surfaces like your tumors or blood clots or some kind of scars in the tissues or some blockages, or there are any infections, you can have these micro robots being launched into the bloodstreams, and then you can carry out these operations of removing the unwanted sites or inspecting a tissue or a blood cells, and then you can see that if it is a normal or an abnormal tissue or a blood cell, and then you can treat them at the site itself, and these robots can perform such kind of an operation. So typically for removal of any diseased areas or any blockages, they can be launched within, they are very miniaturized in size, and they will be moving around and they can destroy whatever is in foreign body. So typically diagrammatically you can see that the nano robots move around the bloodstream. They try to collect any foreign bodies and try to inspect them, analyze them, and in case they are a diseased or a foreign body, they are going to destroy them, and then it is going to be flushed out of the body. You can see that this is what people have been working on. A lot of research is going on in these areas. Many systems are being demonstrated now, and in the future, this is what is the technology which is likely to come up. The next is the micro needles. MEMS based micro needles are very popular now, especially meant for any microliters of quantities of required drug delivery is possible without much injections being given to the person. This have got the micro needles have got capability of drawing the bloods in the microliters of quantity, and also you can do the drug delivery. So what people have been thinking is these kind of micro needles are quite useful, especially for targeted delivery, and you can give the drug to the specific areas where the nerve endings are required, or at a specific site you have to deliver these drugs. These microneedles are quite popular, and this is available quite commercially, and then it's quite popular for targeted drug delivery. A lot of research is going on for the insulin delivery through the watches, where people have been working on, where you can continuously monitor your glucose level in the blood. In case the abnormal sugar levels have been detected, you can automatically deliver drugs with a tank stored in the watch. Of insulins will be measured, quantities will be delivered based on the sugar levels. This is what people have been using in one particular application. You can explore in various applications as well. The smart pill we had already seen. One of the most important application of the MEMS is for the cochlear implant, where the people are not having the natural hearing. Now the painful procedure of implanting a cochlear implant into the ears of a person is going to be very painful. You can see the MEMS based devices will be very miniaturized, very small in size. You can do a surgery at one time and then have this MEMS based cochlear implant with all signal processing circuitries built in, and the cochlea of the person can be reactivated within special electrodes, and then you will see that the person's hearing capability can be brought back. Next is MEMS based devices are being used for bringing back the vision of a person. There is an possibility of at least 50% of a chance of a retina being repaired. So the conventional methods of trying to see the retinal damages and then trying to repair is not quite successful. Now the MEMS based devices are being researched on. You can see that the vision of a person can be brought back to a greater extent. So what are the challenges we are going to face when we are going to work on the medical MEMS devices? One is the biocompatibility. That is one of the biggest hurdle. And these devices are going to be very useful for the life of a person. So you're going to ensure that the person's life is going to be restored back and he is going to join the normal community. And also these devices are very small in size. Handling them is very, very difficult. And how to collect the data out of these devices is also going to be very difficult. Handling these devices is going to be very, very difficult. Also, when you see that when you're going to launch these devices in the body fluids, how do you control them? How do you control these devices at one particular place? How do you make them to stop at one particular place when the blood is flowing, and then to do analysis at a particular location? These are some of the challenges you will be facing in the MEMS based medical devices. The next technology is the carbon nanotechnology. Basically, this also uses the silicon processes as well. So many of you must have studied the properties of carbon nanotubes and other things. I will not go into the basic theory behind these carbon nanotubes. These carbon nanotubes have been quite very well used for the biosensing applications. And not only for biosensing, it has been used for various applications. Here the carbon nanotubes are grown aligned on a silicon surface or on a surface where you can have the carbon nanotubes functionalized for various biosensing applications. And the advantage is the sensors are going to be highly sensitive, and with very smaller amounts of samples you will be able to detect any of the agents what you are looking at, and the results are going to be instantaneous. So similarly, you can see that the biosensing applications are very, very quite useful. And also these carbon nanotubes have been used for the targeted drug delivery. Earlier the MEMS based devices were also used. Now much in the nanoscale, targeted delivery have been quite successful, and these targeted drug delivery systems can reach to particular cell levels itself, and then you can do the treatment at the cellular level when compared to the MEMS based devices. So people have started making these lab on a chip concepts using the combination of MEMS and nanotechnology, and you can see that various agents can be detected on a single go, and it's quite successful. And also for the biosensing applications, a combination of the MEMS and the nanotechnology is commonly used for the point of care of diagnostics testing. The advantages you will get is the very high precision is going to be there. Sensitivity is going to be very good. And if you have multiple agents, you can selectively select some particular agents you wanted to detect. It's going to be fast, and it's going to be highly stable, and there is no kind of any pre-treatment to do the testing and taking the data out. So the data is going to be instantaneously available, The most important thing is you need not have to go to the hospital. You can be at the field or at any place, and you can have the data being analyzed instantaneously. And it is possible to have a personalized care, and you don't need any specialized operator to operate these devices. And these devices are going to be very, very cheap, and they are going to be used and through type. These kind of devices have been quite useful for the bionic eye, where there are various causes of blindness. Blindness can be due to the structural changes in the eye, or due to the damages in the nerve, and then the optic nerve is not able to carry the information to the brain. So the people have researched onto the use of the bionic eye, where an artificial eye is going to be designed. And this artificial eye is not that easy, because the conventional electronics is going to be very difficult, because you need to have a camera, you need to have an RF or a laser, and then you need to build in electronics just before your retina with a lot of electrodes, and then you need to connect to your optical nerve to take the data to your brain for further processing. So you can see that a particular bionic eye has been fabricated. You can see there is a wireless transmitter, there are electrodes, and there is a camera, there is electronics, everything is built into that. This is a typical bionic eye, where you can replace the damaged eye, and then you can have a chances of recovering the vision of a person. So this is what the technologies of the VLSI, MEMS and Nano is playing a very major role in bringing back the vision to a person. The next is the bionic hand. Persons with a disability due to accidents or due to birth defects, they can be brought back to life by giving a bionic hand with better control of doing their routine activities. You can see here the pictorially the muscles what are all available can be used to control your thought process into actions that can be made to function as a normal, at least to perform a routine activity of their daily routines can be carried out by means of this bionic hand. A lot of research is going on in this particular area. The bionic hand is also further extended to the exoskeleton systems, where the persons with a disability, or for enhancing the performance of a person, a lot of research is going on in this exoskeleton systems, where you can try to give in better control of a person's so that he can live a routine life. The next important application of these devices is in the medical imaging sides. The medical imaging is looking at the non-conventional techniques. The conventional techniques are looking into the X-rays, the CT, MRI. They are all very highly conventional now. People are looking at early detection and then looking into miniaturized devices, not at devices which cannot be used continuously, because these kind of an X-ray machine and all, we can't use it continuously on a person. We are looking at imaging techniques where can be continuously used. We can try to see how the disease is progressing. Now the CT technology as such, you can see that they have come into the field somewhere in the 1975s. People have shown that it is possible to do one CT scan of a person, where you will be able to reproduce the images in a manner where you can reconstruct the tumor or an abnormal growth of a person, and then we can see the tumor growth and its size can be measured, and then it can be diagnosed. Now we have seen that very good technologies have come in, where the good imaging have happened, and then multiple generations of the CTs have come. You can see that various types of CT scans have come, and then it has grown into different generations, and then it is available in various forms and factors. And people have even gone into the dual source CT, where there will be two types of sources being used, and then you will be able to have two X-ray systems moving around in the one gantry, and then you will see that data acquisition time will be very, very less, and then you can effectively reproduce the image in a very short time. And then the recent technologies have been the cone beam technology of the CT, where it can be used for the taking a particular image of the body also can be done, and then you can see that different technologies are evolving. And then the MRI has been much used for. Here the MRI doesn't use the X-ray sources. So you can see that multiple types of MRI devices have come into the market, and 3D ultrasounds have also evolved in a bigger way. And you can see that it is possible to reconstruct the face of a person, of a baby which is growing in the uterus, and you can see that it is possible to reconstruct to a greatest nearest quality. You will be able to see the the baby's complete anatomical features, the face, and you can see that the closeness of the matching of the anatomical features of the baby in the uterus and after the birth of the baby is typically almost the same. You can see that. So this is how the imaging systems have been evolving. Now what people are looking at is looking at into a different modality of an imaging where you can see that now you can see that X-ray, ultrasound, nuclear NMR and MRI has got various advantages and disadvantages as well. And now what people are looking at is an imaging technique which will be using non-ionizing radiations. It can detect lesions even less than 5 millimeters, that is meant for early detections. At the early stages of any abnormality can be detect. An imaging system which can have very good resolutions, and it can be used for all age groups because many of the devices cannot be used for younger age population and some of them cannot be used for older age population. So we are looking at an imaging system which will be insensitive to age, and also it should be able to give the metabolic state of the tissue, and it should be an inexpensive tool, and it should be also acting as a screening tool. So what we are looking at is an optical imaging technique. So optical imaging technique has got a number of advantages. So here we are going to use some kind of a laser light source that can be used to image the area of interest or the places where an abnormal growth or where there is going to be some kind of an abnormality is going to be there. Here we are going to use tissue spectroscopy method where we are going to have a method to find out if there is a presence and also if possible the concentration of the quantities which are of interest to us, which is an abnormal growth of a tissue. So that is what we are looking at, and then we are going to produce an image of these abnormal growths, and then we are going to analyze them, and then we are going to see how this is going to be localized into the particular area of the tissue, and then how we are going to analyze and remove the diseased portion. That is what we are looking at. And the next important application what people have been working is on the robotics in the healthcare. So the miniaturization of the robots is very, very important because we are looking into the patient and we are going to do any kind of an invasive surgery or a non-invasive surgery. So the electronics, the microelectronics and the VLSI is going to play a very major role in miniaturizing all these robotic devices, the miniaturization of the motors, the controls, the actuators, the sensors is going to play a very major role. And you can see that this will avoid all the human errors, and then you will see that you are going to have a successful operation being carried out on the person, and it is going to be highly precise. That is what the technologies are now exploring into. When I started my lecture, I said that wearable health monitoring is one area which we will be looking into. So what is this wearable health monitoring system? So the conventional health monitoring system, you must have seen that when a person is having no health issues, he does not go to the doctor at all. And when he feels sick, he goes to the hospital or to the physician and he declares himself saying that I have a running nose or I have a higher temperature. And the doctor is going to do by means of trial and error. He is going to check his temperature, he is going to check his blood pressure, and then he is going to diagnose, and then he is going to by trial and error methods. He might do a blood test, or he might do a urine test, or he may do an ultrasound scan, or he may perform an ECG on the person, and then he is going to do by means of elimination. So if the parameters are normal, he is going to eliminate, and he is going to see at what places the abnormal parameters are reported, and then he is going to do the treatment accordingly. So this is a typical method, and then the physician might recommend him going to an hospital, and then he might ask him to go for admission into the hospital. He might get admitted and he may undergo the further treatments. Now this is a very conventional method. Conventional method, you must have heard about so many things happening now. All of a sudden the person will be sleeping, the next day morning you will not be finding him waking up. He might have died of a cardiac stroke or a stroke, or as such as a stroke or a heart attack. Or you might have seen people collapsing in the office or while performing exercise in the gym, or while performing some sports activities, or performing some very tiring jobs. When they do that, you can see that people just collapsing and dying out. So that is because they might have not taken their symptoms very seriously, and they might have not gone for any kind of a treatment, or they might have not consulted a physician in time. So these are some of the conventional methods. Now what people have started looking at is how do I monitor my health status when I am performing my routine activity, and how do I continue my normal lifestyle when I have an operation or when I have undergone some kind of a treatment. I don't want to stay in the hospital or I'd be at home. I wanted to perform my routine activity. I wanted to work. So for such applications, these wearable health monitoring systems are coming up. So what are these health monitoring systems? Basically, they provide the health status of a person while they perform their normal activities. So it is possible to monitor the health parameters in real time, and it is possible to treat them immediately. And also it is possible to store and retrieve the data of the earlier events, and the doctor can analyze. So what is this need for these wearable devices? So the need for the wearable devices is basically we are looking at maintaining a good health status. Basically maintaining a good health status in the sense, you know that the citizens who are having very high risk like hypertension, obese, diabetes, stress, etc., they will be in a position to maintain a good healthy status of their complete database. And also it is possible to have an early detection of the data by means of trend analysis, and also it will reduce the damage of this severity of these events if it is going to be detected at a later stage.
Sir, Pandian
Yeah.
sir, it's not visible.
1 minute, 1 minute.
Uh,
I think that screen got blocked. No?
Sir, your screen is not visible, sir. I think
1 minute, 1 minute. I'm
you
trying
have
to.
to share once again. Yeah.
Yeah, I'll share again. Now?
not at sir.
Not it, huh?
No, not.
No, sir.
Okay, I think screen got.
Hmm.
No, madam?
Yes, sir.
How much time is left, madam? How much time I can take?
11, sir. Another 5-10 minutes is okay, sir.
I'll
Not
conclude,
issue.
madam. I'll conclude.
Yeah, fine.
So basically for any post-event monitoring, we'll be able to use these wearable devices, and these wearable devices have been used for chronic patients as well to basically understand and manage their diseases. So these wearable health systems are typically finding applications for monitoring the health status of soldiers in the battlefield, or monitoring the elderly people at home, astronauts in space, firefighters, sports personnel. So basically it consists of various sensors distributed onto the body of a person, and these sensors are going to collect the data either wired or wireless, and they are going to be collected by means of an data acquisition hardware. It can be a centralized mobile phone or a specialized device like a watch. They can collect this data and then transmit them to a remote monitoring station. The remote monitoring station is going to have the data and then analyzed, and then the diagnosis is going to be taken or the person is going to be attended to immediately. There are a lot of attributes for these wearable technologies. I'll not go into the depth of these wearable devices. You can see one of these applications of these wearable devices is by means of this Fitbit devices, where this Fitbit had a sensor for monitoring few parameters of the athletes or any kind of a person who's looking into maintaining a good healthy lifestyle. Their parameters are monitored, analyzed, and many of these devices have started coming into market. Various forms of these wearable devices are available. They are available in the form of an head-mounted displays, or they are in the form of a vest, socks, or any wristwatches, or in the form of a clip, and they have an application correspondingly running through that. It can be launched onto your mobile phone. They collect the data, and that can be connected to a centralized nursing station. And these devices are connected through your mobile phone, and they are called as healthcare devices. So various architectures are available for these wearable devices based on the performance what you are looking at. You can build in your architecture as well. And conventionally, most of them are wrist-worn devices, or it is in the form of an wearable devices is commercially available. And these kind of wearable health monitoring systems are very useful. A person like an elderly person at a home can move around, and then he will be able to have the data connected, and there is no need for anyone to monitor him. The data is going to be monitored by a clinician or by a family or by an emergency healthcare provider. When he is going to have some kind of an abnormality in some sort of a heart attack, or he is going to fall down, it is going to be detected, and then he is going to be immediately rushed in and healthcare come in. So the parameters are constantly being monitored and it is going to be taken care. The next important application is the IoT devices. You know the IoT devices, you are going to have interconnectivity of all your devices at your home and you can automate them. This IoT is being very commonly used in various applications. You can name the application, you can see IoT being in that. It can be a smart city or a home or a traffic management, energy management. Everywhere now IoT is being used. Healthcare has been using these devices. The earlier technologies were the wearable health devices. Now people have added the word IoT. IoT in healthcare has got a lot of advantages. I'll not go into the depth of it. In the IoT, you can see there are sensors, there is a data analysis station, there is a decision making, and then there is a doctor or a healthcare practitioner or an expert. And you can see that various benefits are there if you're going to use IoT in healthcare. And you can see basically the architecture is typically a patient with IoT devices distributed either at home or on his body or in his office. And there is a connection layer where you have various forms of connectivity. The data goes to the analysis and storage station. And then from there it goes to the doctor or to the expert for any analysis and then immediate attention to him. So the IoT is based healthcare devices very commonly used for the home healthcare. The person moves around with all sensors and GPS. The parameters are monitored and then the emergency healthcare can come in. So the ambient assisted living is one of the important applications for these IoT devices where your complete house is instrumented and then your body is also instrumented with the devices, and wherever you move around your complete data is being shared, and then any kind of an abnormality in your healthcare or in your walking patterns or in case you've fallen down, the sensors are going to give the data and then you will be attended to. So I'll not go into the technologies. Various communication technologies are used. Very commonly RFIDs are used. Wi-Fi, Zigbee and Bluetooth is the technology very commonly used. Now having collected all this data, how do you store this data? Conventionally, you can see that when you go to an hospital, they are going to store all this data in a paper. Records are going to be either with you or with the hospital, and you might keep changing your hospitals. They are not properly being maintained. So the future is going to be on the electronic health records. What we are looking at is we're looking at cloud computing, we are looking at machine learning and big data analysis. We are looking at electronic health records to present all this data. And natural language processing algorithms are going to be used to study the treatment process which is going to happen and how this data is being analyzed. And then we are trying to see if you have any kind of symptoms or abnormalities which are coming up and what is the risk which is going to be there. And this artificial intelligence will link all your databases, study them and provide them with the history and then what is the likely things which are coming up and what types of medications you are taken up and how the drugs have interacted with you and what is the cause and effect of these drugs and how these suppose if you are taking multiple drugs at a time, how these drug to drug interactions are going to happen. These are all going to be modeled. So that is what this electronic health records is going to play a very major role, and a lot of algorithms are being used. So many research is coming up, and also drug discovery is going to be very, very faster now with all this kind of an electronic health record and then bringing them into the domain of advanced processing of using the machine language or to the natural language processing or by means of artificial intelligence. You can see that drug discovery will be in a very shorter time. That is what is coming up in a big way. To conclude, I will just say in case you are going into the healthcare industry from the electronics field or any other field, what is that you are going to see? So basically the biomedical engineering field, when you go in, you will see that they are the application engineers. They are highly interdisciplinary field. They are going to make applications like diagnostic devices, assistive devices or electronic health records, artificial intelligence, cloud computing, pattern recognition, IoT and wearable devices, robotics. So you can see that the application areas are highly unlimited. You can see that devices are going to find immediate use, especially during the time of COVID. You must have seen a lot of devices are coming. And what are the roles you will have in case you become a biomedical engineer? So basically, medical device designer, programmer you will come, or you can add value addition to the existing devices like CT, MRI, you can or ultrasound. You can build in new functionalities, and even you can go into the device maintenance and research, or else you can go into the R&D field. You can become a scientist or a designer, and you can do statistical data collection and analysis like electronic health records, artificial intelligence and other things can be added on. You can do on clinical validation, or you can do into certification, Or you can see that multi-specialty hospitals have got CT and MRI, they take biomedical engineers. Also biomedical software engineer, where you can develop a lot of software applications. You can see that the field is unlimited. So the future is not limited. The future of medical devices is very bright, especially when you are going to use newer ideas by means of R&D. And also you must have seen during the COVID-19, people didn't even find a single bed in the hospitals. It was all full. Home healthcare has become very important for them because people are advised to take treatment from home only. That is the time where these wearable devices and home healthcare devices have come up. These IoT, M-health, telemedicine have started in a very big way during this COVID time. And then you see that is going to revolutionize the healthcare, because the COVID is not going to stop here. It is going to find multiple variants. So now we have seen that the technologies like VLSI, MEMS, Nano, they are being exploited in a very big way in the healthcare, especially the communication technology as well, especially the wireless mobile phone communications. And now we are seeing that new methods of diagnosis and treatment are being explored in a very big way, especially the COVID, where the treatment process have been shared because none of them knew how to treat and how to go about. So these methods of diagnosis and treatment were being studied and published, and then people started exploring those methods, and that became a model for treatment. So now we have seen that the science and technology is contributing in a very big way for the growth of healthcare. So the major thing is going to be the VLSI, MEMS, Nano, IT and wireless communication technologies will play a major role in the field of healthcare. And now what we see this, because of these technological advancements, healthcare will become more affordable, and it will be, most important thing is it should be available to all. That is what is the important thing you should ensure. Thank you very much. Any questions are there? I can take few questions.
Thank you very much, sir, for your wonderful presentation. Now I will request the participant to unmute. You can interact with the speaker.
Madam? Hello? Sir?
Yes,
sir. You
please
can
go ahead.
proceed.
Sir, in VLSI, you are told both analog and digital, na? In
Yeah, please tell me.
means low power indicator.
No, your voice is
What is the
breaking.
power?
I'm not able to hear your question. It is breaking. Your voice is breaking.
Now it's audible, sir.
Yeah, please tell me.
In low power in the sense, what is the range, sir? It is in milliwatts or nanowatts?
Low power?
Low power, you told, na? VLSI devices which is useful in low power. That should be consumed very less power. It is in nanowatts, sir.
No, I'm not. Your voice is breaking.
Sir, I will come in chart. I will ask question chart, please, sir.
Yeah, please, sir. Otherwise, you do one thing. Madam, you can share my mail ID. I will answer their queries by mail, because his voice is breaking. I'm not able to hear his voice.
Yes, sir, sure.
You can mail him, and then he can ask me.
Sir, otherwise you can type your queries in the chat window also, so that I can read.
You can type also. In the meantime, shall we take the next question, madam? If someone has got any questions.
If anybody got any question, you can directly interact with the speakers.
They can ask. No problem.
Yes, sir. In chat box, sir.
Hello?
Ram Babu, sir, are you asking something?
Yes, madam. Same question I am
Madam,
asking.
can you read the question for me?
Madam, see in chat box I typed.
Okay.
Okay, I posted to that is presenter. I will paste for everyone.
Okay.
Yes, presented too.
I'm not able to see the chat box. No, low power in what range you are asking? It again depends on the devices. See, low power in the sense that It can be in milliwatts or nanowatts, again, depending on the type of application we are looking at. Suppose if you are going to operate a nano robot, which is going to flow into your bloodstream, then depending upon the type of the operation, what you are going to do, meaning that how long it is going to exist and what is your life of those device. Accordingly, you can see what is the functionality. Suppose if you have a light source being built into that, what is the power of the light source, and then how long the light source should last, and then what is the operation you are going to perform using that. Just imaging means, and you are going to have a wireless transmitter. What is the wireless transmission being catered for? What is the data rate? And then how much it is. So accordingly, the milliwatt power is going to be commonly used. So it again depends on that type of an application. It depends on the application.
Thank you, sir.
What is the approximate channel length? Channel length in the sense?
If it is analog, maybe.
Yes, madam.
The data rate you are trying to ask me, or?
No, sir. The distance between source and the drain, we call channel length.
Okay.
In transistor level, sir.
Transistor level, no, that level you have to do the design, because I am not covering in that area. You can just see, I have just brought out all these applications. You can just see what is that is being designed and all, because no, these kind of technology, what I projected to you is to give a light into the application areas.
Okay, sir.
Okay.
Sir, at present in India, which institute there are this biomedical, sir? Which institute?
Biomedical applications, a lot, all these IITs are working on this. IISc also has got a lot of applications.
Postdoc, sir. I am asking about postdoc.
Postdoc. Postdoc, even IISc is taking now, but abroad is better. See, foreign universities are doing quite good. Most of these applications, IISc is also having. IITs I have not seen. Postdoc, most of the foreign universities are much better in biomedical application. Biomedical
Sir, could you
application,
please
if
tell
you're
me
looking
at
at
least one or
innovative
two
methods,
institutes?
it is better to go abroad.
Abroad, which country, sir, for better?
There are so many institutions. It is not restricted. You can see based on the application, and it's all professor dependent. It doesn't depend on the university.
Yes, sir. Yes, sir. Okay.
It is not specific to the university. It is specific to the professor, and the professor who has got the funding, and then who has got that. So if you take typically University of Illinois, they work more onto the nanotechnology. You can see a lot of applications are there. It again depends. So it depends on the professor what funding he has got, what type of an application he is working on. Not specifically the university, it doesn't matter there.
Okay, sir. Okay, sir. Thank you, sir. Thank you, madam. Thank you, sir.
Any other question?
Thank you, sir. Thank you for your precious time and wonderful presentation on sensors and materials and also biomedical devices, sir.
Thank you, madam. Thank you.
We'll have a 10 minutes of break. We'll join after 11:30. Thank you, participants. And thank you, sir.
Thank you, madam. Thank you.
Welcome back, all the participants. Next session is handled by Professor Antara Roy Chowdhury, BMSc, Bangalore. I welcome you, ma'am, for the day 4 morning session.
Good morning, everyone. I hope I'm audible.
Yes, ma'am.
Yes. Just give me 1 minute.
Yes.
I'll start in 1 minute. I'm just sharing the folder with them. 1 minute.
Yes, ma'am.
I hope my screen is visible to all of you.
Yes, ma'am.
So yes, so I'm sharing a link in the chat section. I request participants to please go here and check it out. This is a link of directly a Colab file. Just keep it open, and then I'll explain. Okay, so now hope it is open for everyone. So now, again, good morning, one and all. So, so in the last 3 days, what we have seen, we have started with basic machine learning models, and we have seen that with using the machine learning models, how we can classify the medical data, detect if there is a disease or not. Correct? We have taken multiple examples for that, and yesterday also at the end, you people did the pneumonia detection. I think no, sorry, Parkinson detection. So today, last day of my session, I should say, we are going to check it out with the Python programming with the image data. So just wanted to know the status. Can you just tell that whether Anaconda has been installed or Jupyter Notebook has been installed properly, or else I can go ahead with the Google Colab only. So let me know what is your status. Like yesterday at the end, I was discussing that you people please install the Jupyter Notebook with Anaconda. Is it installed? Okay, one person is telling installed, and you have checked it that all the imports are working or not. No other reply from any other participant. Okay, for one person it is working. What about the other people? Okay, another person has said it's installed. What about the other people? Only 2 people replied. How many people are there? 1 second, let me check. 33 people are there. Okay, so for now, what I'll do, Jupyter web-based application. Yeah, it will open in the web browser only. Yeah, it will launch in Chrome. It will launch in Chrome. Yeah, if the question is it will launch in Chrome or not, yes, it will launch in Chrome. Okay, so do one thing as of now, first without any ambiguity and without any confusion. See, the thing is, you can go ahead and do it with a Google Colab also, but there is some plus and minus. I'll do one thing. It will be mostly the same code. Okay, so no change in the code as such. So I'll start discussing it with the Google Colab only. And later you can do if it is installed, because I'm not sure for all the people that is installed or not. You can try doing in the Jupyter Notebook also. Code will not change in that case. Okay. So what you do as of now, I'll tell you what to be done first of all. Okay. So by the way, what we are interested to do in right now, I want to check it out. My screen is visible, I hope, correct? So I want to check it out with respect to the image data, chest X-ray data. I want to check that whether that chest X-ray relates to normal chest condition, or does it indicate that they have a COVID kind of a situation? Okay, so for that, what you can do, please go to your Chrome and go to Kaggle COVID-19 radiography dataset. Okay, search for Kaggle. I mean, you can go to Kaggle directly also, and you can search for the dataset, and the name of the dataset is COVID-19 radiography dataset. Extremely sorry. Okay, COVID-19 radiography dataset. You open this one. I'm telling the name of the file, that is COVID-19 radiography dataset. Okay, that is what I'm going to use here. So once I go here and open that particular link, so it will say me don't start downloading. Please wait for me. Don't start download. Okay. So it will ask if you want to download it. It can download it, but it's a pretty large size. It is 816 MB. Okay, there will be files of, because it's image dataset, right? There will be files of multiple GBs also. I've taken a small, I mean, in that image data also it is quite small in that case, I should say. It is a size of 816 MB. Now let us see that what is there in this data set at all. You can go down and see the description of the data set. So it says that, so it has the lung X-ray images. Right now it has in the second update we have increased the data set to 3616 COVID-19 positive cases along with 10,192 normal. Okay, and lung opacity, that is another disease that is with the 6012 images, non-COVID lung infection, and the pneumonia infection is 1345. Can you see the description? All of you can go to the link and see that this data set contains this data set will have actually images of 4 type of lungs. Okay, someone is asking me something. 1 minute. One second, let me check. Do I need to install? Can you please tell? Ritvika, it's okay if you have not installed. It's okay. So that's what I just started. If it is not installed, simply it will delay for other people. Not required. You can directly go ahead with a Google Colab only. Later you can try it with a Jupyter Notebook. Doesn't matter. I mean, the concepts doesn't change whether you're installing here or there. Okay. So what you do? So I please explore right now. Don't waste the time to do the installation of Anaconda and Jupyter Notebook. You do one thing. You can first explore the you can explore the data set. Okay, just you explore the data set first. You go to COVID-19 radiography data set and see that what is the distribution of it has. So all of you just go here and check it out. So it has totally the, let me zoom it a bit. You can also check it out in your system. So right now in this situation, I have the total data set of 812 MB, but in that I have 4 different types of images. It says I have one is the COVID-19 images I have of 3,616, and then 10,000 around we have the normal images, and 6,000 around we have the lung opacity case, and viral pneumonia I have around 1,300. Okay, so so now right now I'll be you can do the classification for all the cases. Right now I want to know that whether it has COVID-19 or not, and that analysis I want to do based on the chest x-ray. Okay, so I'll be using 2 things here. Out of all the things, I'll be using the normal lungs x-ray images and COVID-19 images. Okay, other things I'll not use as of now. Okay, so now for these 2 options you have, as we were doing yesterday and all, we can download the data in your local system, and then you can go to Google Colab and you can upload it. Okay, or else there is one more way also, because this Google Colab is compatible with all the other major data repositories. Say that, let it be GitHub, let it be Kaggle. So we'll see that without downloading the data in my local system, how can I import the data directly from Kaggle and do the analysis? So for that, you have to follow some procedure. Just listen to me. I'll do that line by line and you can see it. Okay, so this, I think I have in the chat section, I think all of you would have got the link. Okay, so I would have shared this file to share COVID-19 X-ray images. Okay, do one thing, all of you go to edit and clear all the output. Okay, so that you don't have any previous output. Please open this Google Colab file. Everyone, please open this Google Colab file and click on edit. Open the Google Colab file that is shared, and you can, I mean, by the way, please remember, don't edit that particular file. Please, you copy it in your local system, as we are doing in all the last days. Okay, click on edit and then clear all the output. Is it done? So are you being able to follow? Is this all of you got this file opened? Yes, okay, done. Now, what do you have to do? Let me go to my file now and I'll tell you what are the changes you have to do. Yeah. So first of all, let me also clear all my once again, which file I have opened. I think I have opened some more files. Just give me 1 minute time. Just 1 second, huh? This is not the file because I've made some changes to this. Just give me 1 minute. One second. Sorry for the delay. Give me 1 minute. This is okay, this is a correct one. So I mean, anyway, that's fine. Whatever I've shared with you, that's fine. No issues. You just can see the changes and you should be able to type. So I think all of you have this file. Okay, now let me remove all the output, go to edit and clear all the output. Okay. What you have to do plus code. So first thing that we have to create my data environment. Okay, I mean you have to get the data. So for that, first you import OS. Just execute the line import OS. Okay, and it will take some time because it is the first time you're connecting to the environment, and it will show you're connecting, and then it will connect. Yeah, now it is connected. And import OS, now it is a green symbol, so it is executed. Okay, now if you want to directly download the data from Kaggle, what you have to do, you have to use this line. Okay, you can see it and type OS. And when you see it first of all, then I'll tell you what to be done. Please don't type it now. os.environ, and as a parameter you're supposed to type two parameters. One is called Kaggle username and one is called Kaggle key. I'm repeating, two things you're supposed to use from your user account. One is called Kaggle username and one is called Kaggle key. Now how am I supposed to get this username and the Kaggle? So your Kaggle key, you go here, and I hope all of you have a Kaggle user account. So if you don't have, please create that one. Okay, so please once you go to your Kaggle, go here and go to your account. I'll show the steps once again, nothing to worry. You go to your account settings. Okay, now once you go to your account settings, first of all you will see a field called username. Okay, so my name is Antara Rao Chaudhary, so this is what I have copied here. Okay. So that is my Kaggle username. It has been copied as Antara Rao Chaudhary. Fine. Now, followed by there is one more field with a Kaggle key. Now, where am I supposed to get this Kaggle key? You go down in this your profile, okay, and down you will be getting a section called API. Okay, I'm repeating. First of all, I hope this much is clear for all of you that where I'm supposed to. Please go here and go to your account section. Okay, go to your account section and then copy the username. Okay, username will be the first field that you are supposed to copy. Okay, and then you go to this API section. Okay, and in the API section you click on something called create new API token. In the API, please click on create new API token. Once you create that one, let me go down a little bit. So it will ask you to save a file. It will ask you to save a file, and let me download this. I'm downloading the file. So it will open a file with the name kaggle.json. Kaggle.json file will be opened. Okay, so let me open here and let me show what is the file. So this kaggle.json file is here. Let me open it. You can open it with your text editor. I'm opening it with my text edit. So it will show you, let me zoom it a bit so that you can see it. So this is a JSON file. Actually, you can copy both the things from here. So let me zoom it a little here. So 1 second. Yeah. So this is a JSON file. You can go to your API and download. Not visible. Yes, I'm zooming. Sir, I'm zooming. 1 second. So I'll repeat. Yes, tell me. Yes.
Your presentation is not visible. Are you trying to share it?
My presentation is not visible at all.
Yes, ma'am. That is what.
I mean, from the beginning, when I started from that time, nothing is visible.
Yeah, that was visible, ma'am.
But now it is not visible.
Yes, ma'am.
Okay, I'll share again. Extremely sorry. Yeah. I did not understand only. 1 second. Give me 1 minute.
Yeah, now it's fine.
I'll share it again, huh? I'll do one thing. I'll exit the sharing. I'll exit the meeting and then get the sharing. Can you see now my screen, entire screen? Is it visible?
Yes, ma'am.
Okay, so guys, can you tell me how much it was visible? I mean, I went to Kaggle and I showed you how where I should go to Kaggle and you should go to your user account that you could see. Or else I'll do it again. 1 second. So what you do, this is your file. Okay, this import OS you are supposed to execute. Okay, this much I think it is clear. Now you go to your Kaggle and you go to your user account. Click on this. This is your account and go to your account section. If it is not visible, please let me know. Okay, I'm repeating again. You click on this and go to your account. Okay, and now you go down. Sorry. Now you go down and then go to this API section. I'm highlighting, go to this API section. I'm zooming a little bit. So you will see that phone verification, email ID, and all those stuff. And then down there will be something called API. Yes. Now you click on this create new API token. Create new API token. Okay, you should create on this create new API token, and then it will save a JSON file. I'm saving a JSON file. Okay, I'm downloading a JSON file. Once you download the JSON file, you open the JSON file with your text editor. Once you open the JSON file, you will be able to see this kind of a situation. It will have a dictionary, Python dictionary, which will have two fields. One is my username and there is my key. These are the two values you are supposed to copy. So for me, my username is Untitled, username is something here. So that is what I have copied here. Okay. So what I am doing here for your convenience. So this code is not given in that code that I have shared. This code you are supposed to type. So for your convenience, I'm typing this code in your chat section. I'm giving this code in the chat section, but please make sure that you don't use my username and this key. Go to your Kaggle account. If you don't have any Kaggle account still, please take 1 minute time to create your own Kaggle account, and then you see that whether you can get it or not. Okay, so I'm just giving it this code in the chat section. And after that, what you're so please don't start doing. Give me 1 minute time. I'll tell you after that what you should do, and then you can do it in one shot. I'm just pasting this code in the chat section. Okay, fine. So this is what you are supposed to add. Okay, after this import section, add a code section and then add this one. Okay, now what you should do after this, please don't start doing this one. Listen to me first. Okay, then what you should do, so I have linked this Google Colab to my Kaggle account. Okay, so now I should be able to download it. Okay, so for that, for downloading, the code is exclamatory mark. I think that code I have given to you to share. Let me check it out if that code is given or not. Okay, that code is not given actually. Okay, so that's what it doesn't matter. I'll share the code slowly. So explanatory mark Kaggle data sets download followed by the link of the data set from where you are supposed to get this link. Where is my data? My data is here, right? This is the data. So let me go to the data. Go to the Kaggle account. Yeah, so this is the COVID-19 radiography database, right? And you can see in the browser, this is the link. Can you see? The link is data sets, then slash, then something Rahman, and then COVID-19 radiography dataset, radiography database. So this is the link I have given so that it downloads to my Colab environment. So see what it should happen. So right now it is given as Kaggle datasets download followed by the link. Where from I got the link? I got it from the browser. Okay, this is a step I have not given you in the code so that you make sure that you do it with your own hand so that you know that whenever there is you're directly linking your Colab to the Kaggle, you should be able to do it on your own. Okay, so go to the dataset after kaggle.com, then followed by data set, something will be there. Okay, so you're supposed to copy paste that portion. Okay, fine. So in my case, it will look like this. Followed by, so let me execute this one. So what will happen if I first let me link it? Okay, so right now I have got so green symbol means my Kaggle and my Colab both are linked to each other. Followed by, let me try to download. Okay, so let me click on this. Let me see whether it is downloading or not. Yes, it is. It will unauthorized. How come? Oh, I think 1 second. This copy is I think I have not copy pasted. One second, just give me 1 second. Yeah. So if you keep this key wrongly, it will give you an error. Just now it has given me an error, right? So let me copy paste this value. Give me 1 second. So this is a key that I'm supposed to copy here. So I'm copying it here. Done. So now let me check whether it says me it is authorized or not. Yes, now it is saying me authorized. By mistake, it was some old value, I think. Okay, so it is authorized for me now. Now what I have to do, okay, now anyway, while downloading, I'll get to know. So let me try to download. Why still it is coming unauthorized? Give me 1 second time. Just give me 1 second. Multiple things got downloaded, right? Give me 1 minute, sorry. I'll check which is the last one got downloaded. Actually, to demonstrate to you, I have downloaded multiple files and that became a problem. Just 1 second. This kegel2.json. Let me open it. Okay, so that is the issue. So last file, whichever I have downloaded, that has a different value. That was the issue. No problem, nothing to worry. So, okay, so this is the final key. Okay, I have downloaded it multiple times, and when you download it once again, the value will change. Okay, so right now my last value, JSON file, whatever I have downloaded, that has this value. Okay, let me copy and go to this Kegel key, and this is what I'm copying. Okay, so right now this is, hopefully this should work. Okay, so now let me check, set these variables, and now let me check whether I'm able to download it or not. Yes, it has started now download. So that's what I showed you also. Like so if it is not proper, then it will not allow you to download. So right now my 100% download has been over. So I have downloaded whatever MB was there totally. Okay. Now once you download, what will happen? Go to these files. Now, can you see you had initially sample data only? Normally, I think this environment is familiar to you because last 3 days we are using Colab. That is why I thought initially today I'll start with Colab so that you are familiar with that environment. Okay, so now just let me see that what is the file situation. So this is my files, all the file folders I have, and by default we know whatever data will be there, that will be there in the contents, correct? So let me go to contents. Now, in the inside contents, I have COVID-19 radiography database. Let me try to open this one. It's taking some time to open. Yeah, so 1 minute. So the huge database is taking some time. That's it. It will come. Okay, so now, okay, it will not come. No, how it will come? It is a zip file now. Sorry. Give me 1 second. I'll show you what it is. So whatever I have downloaded. So let me go here. So content. Inside content, whatever I have downloaded, it's a zip file. Okay, so can you see it's a zip file right now? Okay, so as of now, whatever I have downloaded from Kaggle, that will come as a zip file. Now, what you have to do to make it useful, you have to unzip it. So that's what the next command is, unzip followed by the name of the zip file. So execute this. So right now it will take some time for you to unzip. Okay, it will take some time for you to unzip. Okay, so can you see it is unzipping? Still it is unzipping, it's not over. Yeah, now it's done, I think. So once this is done, means it will get you a green symbol here. You can go to this here, and now you should be able to see all the files. So now I have this folder. Okay, can you see this folder? I can expand, and inside the folder I have images of, say, COVID, lung opacity, normal, viral pneumonia. That's what I was discussing. No, we'll have the chest X images of normal heart chest condition, COVID, pneumonia, and all those stuff. What you can do, you can try opening a COVID one. Okay, so let me open. Inside any folder, if you go, you'll be having two folders, images and mask. I'm repeating, inside any folder, if you go, you will be having two folders that will have images and masks. Similarly, if I show you the the normal condition also, you can try opening it. You will have a images and the mask. What you can do, you can go to this images section, open this one. It's not opening for me here. Okay, fine. You can open it with a code also, and you can see what kind of images I have and what kind of mask I have. Okay, so it doesn't matter. So let me see as of now what we have done and what you should do now. You should start doing. I'll stop sharing the code, and then you can choose. So first line is given to you. You're supposed to import the OS. Okay, followed by you're supposed to link your Colab with your Kaggle account with the two property, that is my Kaggle username and the Kaggle key. Where am I supposed to get these two values? You go to your Kaggle account and then go to your user account. I'm going again. Go to your account, go down, and then you check it out the situation of API and create new API token. If you create, that's what, if you write a create new API token, the previous one will get expired, and that is what was happening with me. So that is initially I get the unauthorized error. Okay, when you create on this create, I'm not doing it again because then I have to change the situation once again. You please create a new API token. It will get downloaded as a kaggle.json file. You open the particular file, that file will show something like this, username. So copy the username in the username field. There will be a key, copy it in the Kaggle key field. Okay, and then execute that Colab line. And you, once you execute, you will get a green symbol, followed by you start downloading the data set. Where am I? How should I download? It is the syntax is :Kaggle datasets followed by download. Let me zoom it a bit so that you can see it properly. Kaggle datasets download followed by the link of the dataset that you want to download. From where you should type it, you go here to the Kaggle where I have told you and check it out which dataset. I have told you to search for the dataset as COVID-19 radiography dataset. Once you go here, you will see this one. Okay, dataset. After that, the link of the dataset will be given here. Copy paste that portion, and you should be able to download. Once it is downloaded, it will be coming as a zip file. I have shown you, and then you unzip the file, and once it is unzipping, it's done. You please go to the file section and check it out that whether you are getting all this folder directory or not. Okay, I hope I am clear with the instructions. I request everyone to please start doing now and check it out. Are you being able to load the data directly from the Kaggle or not? All the image data is coming to you or not? Please start doing. Anywhere you are stuck, you let me know. And once it is done, you let me know so that I'll do the further processing. I'm muting myself. You please do follow all the steps. Once any doubt, chat section is open only. You can ping in the chat section if any doubt or if it is done. So are you being able to, can you, is it working fine? Kaggle and the Google Colab, they're getting connected to each other? Let me know if some step you want me to repeat. Is it done for anyone? All the steps? Showing the code for you also. If you want me to give the code in the chat section also, you can let me know. So you should first do this 2 lines where you are linking it, followed by make sure you download this database, okay, and then you unzip it. There's 4 lines. So we have some message here. Let me check it out. Not working. Yes, loading, ma'am. You got a warning like this. Warning, you were connected to. Yeah, that's okay. Not a big deal. Change to standard runtime. That's okay. Can I suggest Kaggle dataset download command in Jupyter Notebook? Yeah, you can link it also. You can do, no problem. The dataset download will take some time wherever you are doing. Dataset download, whatever you are doing, wherever you are doing, Jupyter Notebook or also, because ultimately you have to download the dataset. So that will take some time wherever you are doing. How much percentage it is done? For me, it happened very fast. Actually, it depends on your network speed as well. So where you are stuck, you could this unauthorized error is gone. Okay, unauthorized error is gone. Then dataset download working. Okay, so someone said it's working. Working means up to you. You can see the folders in your here there. You see the folders. Yes. Okay. So one person completed it. Good. The other 2-3 people, if they say it's done, then I can continue. Other 2-3 people, please confirm that it's done. Okay. No, I'll wait. It is done. I have done it in Colab. When I run the same command in notebook, it says Kaggle is not recognized. Kaggle is not recognized. Where it is showing? Notebook means Jupyter Notebook, you want to say? So with Jupyter Notebook, what I suggest is you can do one thing. What I have done with the Jupyter Notebook, I'll show you. Once again, I don't want to people confused with so many syntax. So what you can do, I have 1 minute. I'll show you. Right now, let's all of us do it in one thing, that so that all of us we can finish it. Otherwise, too many syntaxes with too many different environments, it will get confusing. So what you can do, so this is where I've opened my Jupyter Notebook. It is some other thing, but that doesn't matter. What you can do, so if you're using Jupyter Notebook, okay, I'll suggest you download it. Okay, you download it directly in your system. Okay, so right now this is one CSV file. Okay, this is one CSV file that I have downloaded in my, okay, by the way, is it visible my screen? Okay, I'll show you what I'm doing here. If you're okay, by the way, please don't do this right now, because otherwise so many things will get confused. Okay, so this is syntax for your Jupyter Notebook. So let me import all the libraries, run. Okay, so once it is done, you can load it with the pd.read CSV followed by the CSV file. Okay, this is the same syntax whatever we have used yesterday. I mean the PD is your pandas.read CSV, and followed by give the name of the link. Okay, and then you make it run, and then you can load you can check it out what is here and all this stuff. You should be able to do it. Okay, so if you're keen to use notebook, make sure I request you to please download it, and then you specify the path. Okay, so how in the downloads or wherever you have saved that CSV file, you can mention that particular path there. It's asking me to reload. Okay, but it doesn't matter. So you can do it with a read CSV, whatever you have done yesterday. PD is pandas.read CSV. Okay, that should work for you. Okay, so now, okay, now let me go to my where I was. This is the Colab. Okay, so right now I have unzipped all the folders. Okay, unzipped all the files. So I have got all this. Can you see all the things that we are getting it? That is my either PNG. I mean that those are everything is my image. Now what you can do to check out that what we have in these files. What you can do, you can execute the command as so. You want to check. I want to check how many images are there in the data set. Now in this data set, if I look at this particular data set, let me again open. So this is a data folder, right? COVID-19 radiography data set. So it has a folder as major 4 folders: COVID, lung opacity, normal, and viral pneumonia. Okay, and I told you right now I'm interested in two image data sets. So one is my COVID, another is my normal. Yes, COVID and normal. So what I'm doing, I am first checking that how many, basically the size, I mean how many COVID images I have and how many normal images I have. Okay, so for that what we have done, first go to that particular path of the COVID data set. So that is my COVID-19. This is how to go here. COVID-19 radiology data set / COVID. This is normal how we navigate from one folder to another folder, correct? Because this COVID is a subfolder under this COVID-19 folder, and in that COVID folder, I want to go to the images. So I'm going from here, COVID-19 radiography data set to COVID and to images, and I'm to append it as a path. I have given the command, Python command as os.listdir, followed by I have given it as a length. Length means it will give me how many images I have. So if I execute this one, these codes are given to you. You can directly use it. It will give you 3616. It's the same value what was mentioned in Kaggle also, correct? So I know I have loaded the data properly. Then I have the COVID images. How many COVID images I have? I have the COVID images of 3616. Okay. Now followed by, let me check how many normal images I have. So for that also, what you have to do in the COVID data set, you have to go inside the normal folder. Okay, so for initially I have gone to the COVID folder. Now I'm going to the normal folder and I'm checking how many images I have. So I can see that there is a slight class imbalance is also there, because if you see here, I have COVID image of 3,600, whereas normal images are quite much more than this. That is my 10,000. Okay, but that's okay for now, doesn't matter. So right now you you can check out the size of the data. Okay, now so what I want now, let me just see that how the data looks, because initially you could open directly the data set and you have seen it as a CSV file, right? Something comma like that. It was a CSV file, right? Now when you want to see the image, what you have to do, you can import the OpenCV. Okay, so to see the file, let me close it. To see the file, you have to you have to use the OpenCV library. Okay, so what you have to do, you have to execute the command import CV2. Okay, I'm executing it, import CV2, and then what I want to read a file from the normal data set. Okay, from the normal. So if I remove, let me just write it in this way. Okay, so let me leave it off 1 second. So let me type it only. So COVID-19. So this is your folder, correct? I want to check it out, one data set, one image inside this. So what I'll do, you can go to normal, you can go to COVID. So right now I'm going to normal, and you can go to inside normal. So you can go to normal and you can check out the images. So right now I'm going to image inside the normal. I'm going to the images folder, and the first image, the name is normal -0005.png. If you're not sure what are the name of the files, you can go up and you can see here. If you go this section up, you should be able to see. Right now you're in the pneumonia section. You can scroll it up and you can go to your normal data set also, and you can see it which was in the first file. Okay, or any other file, you can see the pneumonia files also. You just need to see that how the file looks. Okay, so import CV2 followed by, have given a name of a file. You can give it any PNG name of a file. Okay, doesn't matter. You can use the pneumonia set also. So right now let me execute it. So this command has executed. So it is my imread, cv2.imread command to read the PNG file. To show it here, what you have to do, first you have to take the reference of the matplotlib. Yesterday also we did it, matplotlib.plt. So I'm importing that matplotlib library, and followed by in that matplotlib, that is plt. With that I'm executing the command iamshow. Okay, so what we have done, we have initially imported our OpenCV. Have imported the OpenCV library. With OpenCV reference, we have executed the command imread to read the image, and now you want to see the image. I want to see for myself how the data looks. Okay, so for that you have to use the matplotlib library, and on the matplotlib library reference object, you can execute the command iamshow. Okay, so execute it. Yeah, so now you can see that for all the images are looking something like this. This is a chest image. Yes, so this is how it will show you that this is the image you should have. Okay, now so if you want to know that what is the shape or what is the size and shape of this particular image, you can use this img.shape, and it is showing me I have 299. I mean 300 by 300. You can see it here, 300 by 300, totally 299 means, yeah, 0 to 299 rather, 299 by 299 multiplied by 3 RGB. So 3 values. So this is my this is the image data I have. So what I have done, I request everyone to do this much first. So what you can do here, first you check it out, what is the number of images in the COVID folder. I have checked what is the number of images in the normal folder, followed by import the OpenCV library and use a function imread, followed by import the library matplotlib, and then execute the file iamshow. Okay, and see that iamshow. After the iamshow file, you should be able to see the chest X-ray image. You can use any other image also and see that how it looks. You can try to load one pneumonia image and see that how it looks, and visually how it changes for your understanding. So make clear that what has to be done. So please do up to the instruction when you can see this codes are there in the shared file. So it should not take too much time, and then you can check out the size of the shape of the file, or the size of the image rather, I should say. img.shape will give you the size of the image. That is 299 by 299 cross 3. So check it out whether you are getting this much or not. Once it is done, please message in the chat section as done. Once it is done or any doubts, please feel free to let me know. Okay, I just restored, it's done. I request another one or two people to confirm it's done so that I can proceed. So right now, what we have done, we have linked my Colab with Kaggle directly. I could download it directly the data. I mean, without it will help you if you do not want to waste your system space. Directly, your system, if it is low in memory, then it will not burden your system. So download the data directly in your Google Colab and then use it and see that how the image looks. That much we are done. Let's finish other people. I'll wait. Let me know once I should move. Is it done for other people? Can I move? Can I proceed? It should not take too much time because all the codes were given only. Please let me know whether I can move. Or do you want me to wait? I'll wait for 1 more minute. It's 12:23. I'll wait up to 12:25. Is it getting stuck somewhere? Ma'am, I stuck at 3rd step. It is better you can reconnect and do that. It should not take time. If you check that whether you have given the Kaggle key and username properly or not. Download the JSON. If you're re-downloading it, make sure that you change it again. It should not take time. I did it twice and thrice in front of you. It just finished in very fast. It will not take time. So are you getting the download started this much you are getting, or that is also not coming? If the download started is also not coming, then it means that it is failing at the username and the user key, Kaggle key you have not used properly. Where it is getting stuck? What is yes, ma'am? It is downloaded is started. How far it is done? Okay, 2 minutes I'll wait. Okay, no problem, I'll wait. That is already 12:25. I'm continuing. You people keep doing so that like other people who are waiting, they can start. Okay, I'm just explaining. You people can keep doing parallel. Okay, so now, so right now I've seen that what is my data, and I know that how many normal images I have and how many COVID images I have. Then to do it with the data processing, I know what are the library I need, because last 3 days we are doing with the same thing. You are going to need pandas for the data frame and NP, that is NumPy, for the data processing. Yeah. So import pandas as PD and import NumPy as NP. So it's done. So these are the two library we have used from the first session onwards. Okay, so this two is done. Then what we have to do, you see, there is one Excel is also there. If you want to check it out, where is that Excel? Okay, let me show this Excel where it is. It is a metadata actually. So if you see here, this COVID-19 data set, it has this COVID images, it has this lung opacity images, it has the normal images, it has a pneumonia, viral pneumonia images is there, and it has something called pneumonia is done. It has something called COVID.metadata. Can you see here? There is something file, Excel file. Apart from this 4 major folders, it has a metadata folder. Metadata file. Metadata file means it will show you some information about the COVID folder. The COVID folder of the information about the metadata about the COVID folder. Similarly, we have the metadata information for all the other folder, for the lung opacity also, for the normal also. Let me just try to load and see that what I have as a metadata folder in the COVID. Okay, for the COVID, what metadata information I have. So for that, what I have to do, you can, it's as it is an Excel file, you're supposed to use read_Excel. Okay, that much I hope all of us understand. If it is a CSV file, I'm going to use PD or pandas dot read CSV, read_CSV. If it is an Excel file, I'm going to use read_Excel. Okay, so let me see it here. Let me execute it. And then give it ef.head, and see, it will show you that the metadata about this, that I'll have, you can see that I'll have the file names as COVID-1, COVID-2, COVID-3, something like this, and all the files are there in the PNG format, and all of them are with the size, I mean, each and every PNG file in the COVID folder are with the size 256 cross 256. It is 255 by 255 size. Okay, per 255 by 255 pixel size. Okay, this is an image it will say, and it is available at which particular URL, that is also getting shown. Okay, now what I can do to go to the particular images, now I have to go to the particular image and check out. So if I execute this, let me execute this one. What I want to do now, I want to go to the folder COVID-19 radiography dataset, followed by COVID, followed by image. This is the, so I have os.list directory. It will give me the path. Okay, I hope all of us, we know that os.list directory is used to create the path variable in your Python. It is used to set the path, correct? So right now my path has been given as path as of now is up to this is done. COVID-19 dot dataset dot slash COVID slash images. I mean, I have gone up to this level. If I go to this file, I have gone up to this COVID-19 dataset followed by COVID followed by images. I am here. Now I want to loop through or navigate through all the images. That's what is my work, right? I have to go and check it out. What are all the images, and I have to extract the parameters, correct? So what you can do now, I have to go to each and every image. So for that, to go to the first image, let me execute this one. To go to the first images, you are supposed to use URLs 0. First use. From where this URLs is coming, the URLs is coming from here. Okay, URL, if you have seen this, I have used this metadata file, correct? Where from it is coming, you have tried to read the metadata. You have printed the metadata head, you have printed the first 5 rows, okay, and that first 5 rows will give you the name of the file followed by the format as PNG, size of the file followed by URL. Okay, now if I want to check out my first image, that is there as URL 0, correct? That is at the URL column at the first index. So that's what we are doing here. Right now I am setting the path of my first image in the COVID directory. So it has been set as COVID-19, whatever the path is there, followed by, this is a path up to the images directory. This is a path of the first image in the images directory under the COVID folder. So this will give you the path of the total the path up to the first image in the COVID folder. Let me print this path. If you print this path, it is giving you the total one. It is giving you the radiography dataset folder, the slash COVID slash images, followed by the PNG file. So first PNG file has this name. Okay, this is the first file in the COVID folder. Okay, now what we have to do, we have to load all the images. See, here we have manually done it for only one. Okay, they have got the link of only one and done it for only one, but I have to do it for all the images that are there in the COVID folder, and also the same thing has to be done for all the images that is there in the normal folder, correct? Now what we are doing here, you can create a function called, it's a Python function you are creating, def load images. I want to load the images, and the parameters are path, URL, and target. Now what are this? We will come to that. What we are doing first, we are initializing it as an empty list. So it is my images is nothing and labels is nothing. Okay, then what I am doing, I'm looping over all the images in the directory. How am I looping? For I in range length of URLs. Where from this URLs is coming? Check it out. What is this URLs, by the way? This URLs is this one. Okay, URLs is this one, correct? So this URLs will give you how many totally. This URLs is set to I mean the it is a list of all the images in the COVID directory. Okay, now I want to loop over all the images that are there in the COVID directory. Okay, to loop over all the images, what I have to do, I have to just, it's a basic for loop which will start from 0 up to the URLs dot length. I hope I am understandable. I'm clear with it what I'm trying to do it. I have first checked that how many images are there in the COVID folder. Now I want to loop through all the images that are there in the COVID folder. Okay, so I know what is how many number of images I have. That is same as URLs dot length or the length of URLs. Okay, so that's what I'm doing. We are looping for I in range of length of URLs. What we are doing, we are saying image path. I mean path of that particular image will be equal to path. What is this path? Path is this one. Okay, this path slash URLs of I for that particular URL. What will be the, okay? So now, so that is how this your path will be getting modified, and you will get the path. This will give you, first it will give you the path of only one. So that's what we did here. If you see here, that is what has been done here. So initially it will be URL 0, after that it will be URLs 1, that, and then it will be URLs 2, like that. Okay, so right now, so it will go to the first image, then it will go to the next image. Now for each and every image, what we are doing, as I have done it before, for a particular image we have done, first to read the image we have to use the imread. Okay, cb2.imread followed by the path. Okay, Then followed by, as we have said, I have shown you the size of this file, and the file is 255 by 255. Can you see the size of the file is 256 by 256? I mean 256 means all the values will be there in the range of 0 to 255. Correct? The size is 256 cross 256 means the size, the values in the each pixel value of the file will be 256 to 0 to 255 range. So to normalize the data, we have done IMG divided by 255.0 because all the data will be there in the range of 0 to 255. To bring it down, to normalize it, it has been done as divided by 255.0. Okay, so right now what we have done, then we are resizing all the folder because right now the size is too big. You have to resize it so that it is processable afterwards. We are resizing each and every image as 100 cross 100. Okay, and then we are appending it with the IMG, and we are appending it with label. Okay, labels.append will be equal to target, followed by we are passing it as the images array, and followed by we are returning the images and labels. Let me just show this what it actually happens. So what is the use of this one? Let me first make you understand that what is that we are trying to do. So I know the data is there. Now we want to loop through. I want to read all the data belonging to all the files. Okay, so we have to go to the location of the file, and from there you have to loop over all the files. How to know that in the folder what are files I have? You can check it out in the metadata folder. In the metadata folder you will get the URL of all the files inside that. Okay, so you can loop through all the files inside those URLs, and you can load it. How to load the files? You have done it before only with the imread command. Correct? Here only when I have shown you for only a single file, we have done it with the imread. Correct? cv.cv2.imread, where cv2 is a reference of your OpenCV, cv2.imread. If you want to show it on your screen, then you can use imshow. But right now we are just trying to load all the data of all the images, so I'm not doing any kind of show. I'm just leaving it with the imread. So that's what has been done here in this load images function. So this is a function we have defined up to this, and then we are calling it. So please do up to this and see that whether you are getting it or not. I request you to please do it up to the where you're defining the load images. All the functions are given. It should not take too much time. Here we are defining the load images function. Okay, here you are defining the load images function, and you will call it down. Okay, we have to call this one down here. And load images, you have to call it 2 times. Once you have to call it for the folder COVID, and again you have to call it for the folder normal, because 2 types of image you are supposed to load it in your environment. One is the COVID images, other is a normal folder, sorry, normal images. If for the further analysis, you can extend the project, you can load other images also that is there in the lungs opacity folder, or that is there in the pneumonia detection folder. Okay, so that is how you should read the image data with the cv2.imread, and followed by normalize it. But as it see the size, if it is generally, it will be from 256 pixels will be there. So divided by 255, because all the data will be there in the range of 0 to 255. Okay, so that it brings it down. To normalize it, we are just doing everything divided by 255. So check it if it is working or not. Up to this. Then I'll explain what about this. This too I have not explained. Please leave it off. Up to this, if it is working, you're getting everything as a green symbol, it's done. Because it will not show you any output. Here only you will get some output that I have not executed and I have not explained also. Please see it after that when the definition for this load images is executing for you or not. You can define this function load images or not. This function will be used to load the images and do the normalization as well. So let me know once it is done. Already 12:40. Let me see what are the new files I have. Carry on. Okay, that is the previous one, I think. Okay, finish it up to this and let me know. So as of now, I've shown you how you can load it. Then we're going to load it for 2 folders and we'll see how to do the analysis for this. Done. Okay, one person has said it's done. I'll just wait for the other 1 or 2 people. The people who are done, they can just try giving a I am show command. Just play around a little bit with the code for a particular file. You don't give it for all the I am sure don't give it for all the loops, because in that case you will end up in crashing the RAM, because then it has to show all those 10,000 images. Like 1 or 2 URLs you can take and just try it out, that whether it is you can view it or not. And all the codes, like I'm sure everything is working for you or not. You can just play around a little bit with the code instead of waiting. Should I wait? Okay, like last 2 minutes I'll wait. Then I'll start. Are you following? There is a feedback form link. Am I clear with explanation? Are you being able to follow? Can you follow, or any step I should re-explain? Thanks for the feedback, madam. Okay, now what does it mean by we are sign off? It is not working for you? Yes. So, unable to follow. From where I should follow, where I should start, you tell me. Okay, by the way, I'll explain that IMG.255, it will normalization for the normalization, madam. So because everything normally, if you see an image, no, it will be because RGB values will be there, right? So all the values will be somewhere between 255. Correct? That's what we know. For any image, if you see here, all the values will be there in the range of 0 to 255. If the value is all 255, then it's a RGB full, right? That's what we know. So that's what, to bring it down, because so see, to downscale it, I should say, to downscale it, we should divide it by 255, so that all the values are now in the range, say 0.2, 0.3, 0.8, so that your whatever processing you are doing, that is not bothered with a large number, because ultimately the balance between the R, G and B values matters. Correct? Because every image is a mixture of these RGB values. Instead of making all this R, G and B in the range of 0 to 255, you are bringing it down as a smaller numbers. So you're normalizing all the numbers. So you're bringing it down between a range of between 0 to 1. It will be some positive number, it will be some decimal number between 0 to 1. So that it is easier to work with a smaller number afterwards. That's it. Just a downscaling, bringing it down, nothing else. So I hope I answered the question. It's called the normalization or scaling down, you can say. So I just explain for the people who told it is not understandable, or so I just show again what we have done quickly. So as of now, we are stuck here. We have done up to this, that we have defined a function load images that should load the images for me, and when it is called, and that should divide all the image values by 255. Now I have to load the images of two folders. One folder is my normal, another folder is my COVID. So for the people who are getting confused, now the next steps will be easy. This will be just using these functions. You can just click on it and you should be able to understand, nothing much. So here we are just defining the function. Now let me call it. We have to call it two times, once for the normal and for the COVID. So right now I'm going to the folder. First path I have set it as up to the COVID images. Okay, so right now you want to load which images? COVID image you want to load. So this is this path. If you write this, if you load right, it is a string, correct? It is concatenation of a string. Now to make it a path, we have to use it os.listdir. That's what I guess everyone knows is the use of this os.listdir command in a and a Python, correct? So this is going to be my path. Okay, so this will give you the path up to the COVID images. So this COVID URL is my path up to the COVID images. So now what you have to do, I have to have right now what you have, I have this data as an input, correct? But if you remember, what is my job? My job is to do a classification, and classification comes under our supervised learning. I'm repeating, all of you should understand this step, what we are doing. See, what you have now, you have two folders. I have a folder called COVID. I have a folder called normal, correct? But I have to do some classification. Classification means it should be a labeled data. Correct? Yesterday, and whatever we have done, say if this is a cancerous tumor, it will be labeled as 1. If it is a benign tumor, it will be labeled as 0. Correct? Right now, whatever data you have downloaded from this image data set that doesn't have this labeling 0 and 1, it is just categorized in different folders, COVID, and it has been categorized in another folder as normal. So what I have to do now, I have to give this 0 and 1. The labeling has to be done. Am I clear? Until and unless you give the labeling 0 and 1 or whatever other labeling you want to give, you won't be able to proceed with the classification work, because classification says that it has to be a labeled data. That's what we have discussed long back. So that's what we are doing now. We are doing the COVID images. The COVID images is my image data, followed by the targets. Targets will be either 0 and 1. How we are doing it? We are saying call the function load images, load it from this path, COVID URL and all those things, go to the path and COVID URL and make it 1. The target should be 1. So right now we are loading the image as a data set in my environment. Now it's a data set in my environment, where every data row has been marked with 1. 1 means it's a COVID positive. The same thing if you want to execute, just see the length. Oh, sorry, I have not executed this one. Let it execute. Right now it is loading in your environment as a data set as such, labeled data set. So right now it has been loaded. Let me check what is the length. Yes, this is 3616. Correct? That is what is how many number of images I had in the COVID. So now every COVID data has been marked when it is loaded in my environment as a data frame. It is marked as a 1. Now what I have to do for the normal data set, for not a normal data set, every image should be labeled as 0. Every data should be labeled as 0. So that has been done. Let me execute it here. So that's what has been done here. Load images function when you're calling with the normal path and normal URLs. Normal path is up to the normal folder. Okay, repeating, normal path is a path up to the normal folder. The normal URLs is all the URLs which will give you all the individual files, and for each and every file you should append it. Each and every data should be appended with the label 0. I hope these two steps are clear to you. These two steps are done so that you can proceed with the classification task. All the COVID data has been labeled now with 1. All the non-COVID data, I mean the normal folder, we have labeled it with 0. And if you print it now, wait, just giving me, sorry, I missed it. One second, it should be 0 should be inside. Okay, don't confuse. The 0 should be, by mistake it got here. 0 should be here. So let me execute it once. We'll connect, wait. So it's done now. So now let me check this COVID images.shape and the normal images.shape. So this shape command I'm using means it's my data frame now. So COVID images, it's there as my, how many rows are there? It has a rows as 3616. And each and every image I have said my size should be 100, 100. If you remember where I have set it as 100, 100, here I have set it. If you remember, it has been done here. All the images has been resized with the sizes 100, 100. And 3 is for the 3 pixels RGB. So COVID images has 3616 data values. Each one of them are of the size of 100, 100, 3. Now let me see what is the situation of my normal images. In the normal images, I have 10,000, whatever was the total line was there in the, I mean, however image, how many ever images were there in the normal folder, this 10,000 images were there. So this data also I have loaded in my environment. Now what you have to do, you have to have, now imagine how we do for the normal classification. Normal classification means I'm going to have a big data set, correct? A big data frame will be there, which will be a mix of all the data set that is belonging to one category, all the data sets that is belonging to 0 category. That's what you do when you download a CSV file, correct? So right now I have two separate things. One is with all 1, other is with all 0. What I have to do, you have to merge both, and so that you can apply the classification algorithm and you can apply the training, testing, and all this stuff. So that has been done. np.r hyphen, np.r hyphen, this np is a full form, np is a short form of your numpy, okay, numpy reference. Numpy reference dot r hyphen function, what it does a row wise merge. Okay, so what it will do, first it will merge all the row of COVID images, followed by it will merge all the row of normal images. So ultimately it will give you a data set of around 13,000. I think this 10,000 plus 3,000, around 13,000 plus rows, in which the initial 10,000 will be all, initially all 3,000 will be all ones, and the remaining letter 10,000 will be all zeros. But that doesn't matter, because ultimately that whatever data set you have totally, you have to divide it in the two portions, that is my training and testing. And once we divide it in two portions, training and testing, it will be a randomized division, right? So that 1 and 0, whatever is there now in one portion, that will get mixed, doesn't matter. Let me check it whether I can execute this much. Okay, so right now I have done a row wise merge of the COVID data set with the normal images. Let me execute this data.ship. Yes, can you see it is right now I have some around 13,000 data set, which is a merge of this two. So this one data is my final file on which I should be able to do the classification. So okay, so as of now I have done all the pre-processing and all this stuff. Now this is the data on which I should be able to write my classification algorithm, and we'll be using here CNN. Okay, CNN or the convolution neural network. Okay, so now what we, okay, by the way, I'll request everyone to please do up to this, just see that up to this data.shape is working for you or not. Please check that up to data.shape, you should be able to get some 13,000 plus data rows. Please do up to this and let me know once it's done. Let me know whether you are stuck at a point or. Right now, this data is my final data on which I should be able to do my processing.
ಹಲೋ
Hello.
ಸರ್, ಚೇತನ್ ಸರ್, ನಾನು ನಾಗರಾಜ್ ಅಂತ. ನಾಗರಾಜ್ ಜ್ಞಾಪಕ ಹ್ಯಾಬಿಟ್ಯಾಟ್ ಅವರ ಅಲ್ಲಿ ಒಂದು ಫ್ಲಾಟ್ ತಗೊಂಡಿದ್ದೀನಿ, ಬೈರಿ ನೆಗೋಸಿಯೇಷನ್ಗೆ. ಸರಿ, ನಾನು ಬೆಳಿಗ್ಗೆ ಟ್ರೈ ಮಾಡಿದೆ, ಸಿಕ್ಕಿಲ್ಲ.
I request you to please mute yourself.
ಫ್ರೀ ಇದ್ದೀರಾ, ಮಾತಾಡ್ಬೋದಾ? ಸರ್ ಏನಿಲ್ಲ, ಆಕ್ಚುಲಿ ನಾವು ನೆಕ್ಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿಗೆ ಮೂವ್ ಆಗ್ತಾ ಇದ್ವಿ. ಈಗ ಹ್ಯಾಂಡ್ ಓವರ್ ನೆಕ್ಸ್ಟ್ ಇಯರ್ ಎಂಡಲ್ಲಿದೆ. ಬಟ್ ನಾನು ಈಗ ನಮ್ಮ ಮಕ್ಕಳನ್ನ ಅಲ್ಲಿ ಸ್ಕೂಲ್ಗೆ ಮೊದಲೇ ಅಡ್ಮಿಷನ್ ಮಾಡ್ಬೇಕು. ಈಗ ಯಾವ್ದು ಸ್ಕೂಲ್ ಚೆನ್ನಾಗಿದೆ ಅಂತ ಹೇಳಿ, ಯಾವ್ದು ಅಂತ.
By the way, let me just tell the last two steps because what you
ನನಗೆ
request all the participants please to mute themselves.
ನೋಡಿ, ಅಥವಾ ಕಂಪ್ಯಾರಿಟಿವ್ಲಿ ಇನ್ನೊಂದು ಇದೆ, ಕಾರ್ಮಲ್ ಹಳೇದಲ್ಲ, BGS ಇನ್ನೊಂದು ಯಾವ್ದು ಹೇಳಿದ್ರಿ, ಇನ್ನೊಂದು.
So as of now, what we have done here,
ಬಂದು ಇನ್ನು ಸ್ವಲ್ಪ ಮುಂದೆ 5 ಹತ್ರ ಬರುತ್ತೆ.
I request everyone to please mute themselves. So if you see here, when we are doing this appending with 0 and 1, we had actually two variables, correct? COVID images and the COVID target. These images will have the image data, and this COVID target, that's my target variable, will be equal to 1, correct? For the normal thing, as we have discussed, it will have all the images data, followed by it will be 0 for all the aspect target variable. Correct? That's what we have, right? Always we have a data set and followed by the data and the target or the output variable. So the target is my output variable. Here it is 1 and here it is 0. And when you are doing a row-wise merge, you should do two row-wise merge. That's what we were discussing. One is your data, the featured data, that is my images data. Okay, so we have merged the images data. Right, so this images data will be of 13,000 images data will be there, where each one of them are of size 100 cross 100. So this is my images data you are merging. Followed by one more thing also you are supposed to merge, that is my target data. Correct. So the target data is my np.merge, that is my COVID target dot normal target. So this is this COVID. Let me see the size of this one. It will not come. I have not executed this one. So what it is basically, this target is a series of 1 and 0. Initially it will be all 1 for 3,000 COVID images. Later it will be all 0. So let me just execute it and you will see it. Yeah, so you can see it. It's just a one column only. So that's when the next column is left blank. It is a 13,000. So this is the 13,000 data. It is actual image data, and this is a label for all the data. The label has been named as target. Is it understandable? Right now, this is my input. Sorry. This is my data.ship. This is my input file, and this is the targets one. Okay. So this, if you imagine how we do it in the previous sessions and all, we already something as a X and Y. X was your data and Y was your label, correct? So with that terminology, I should be able to say this is my X, this is my Y. So now this X has to be divided in two parts, training and testing, followed by this Y has to be divided in two parts, training and testing. Okay, so yeah, so I'll do one thing. So is it done up to this? Done. Okay, so one person has said it done. So so what is the time? It is already 12:58. I'll do one thing. So all of you, whoever is done, it's fine. Otherwise, if it's not done, please finish it off. So as of now, we have my data set done, ready. My X and Y is ready. Now we are supposed to divide X in two parts, Y in two parts, and followed by I have to train my CNN, correct? So those will have a lot of parameters that I'm supposed to explain before lunch break. I don't want to do that. All this is this much only here. This is the only thing which is remaining. The dividing and test and training part, followed by creating the model. Okay, creating the model here. So that I'll do it after the lunch break. That would be better, I feel. So I request all the participants to break for lunch now. You can break for lunch now and come back at 1 o'clock. Sorry, 2 o'clock. I feel that's fine. Any doubts you have up to this, please keep it ready up to this this line where you have the data and target ready. Okay, and the data should have 13,000 value and the target also should have 13,000 value, but the target should be only one column. Please keep it ready up to this and then you can break for lunch. I'm stopping their sharing for me. Any doubts you can ask me. We are online up to 1 o'clock. Any doubts you can ask. Okay, thanks for your inputs. Okay, well, let's get back at 2 o'clock.
Thank you, everyone. We'll take a break and we will resume back at 2 o'clock. Good afternoon, everyone. Good afternoon, ma'am. Welcome back, all the participants, for the next session.
Good afternoon, everyone. Start. All the participants are back. Still 20 people are there. Okay, so I'll stop the sharing and start it again. By the time other people are joining us, I'd like to play some video and by the time hopefully the other people will join us. Let's see what is about CNN. Some details about CNN convolutional network. By the time hopefully other people will join us. There's still 20 people are there. No, let me know whether it is audible, huh?
Properly written and rendered at
Yes,
an
ma'am.
extremely low resolution of. This is a 3. It's sloppily written and rendered at an extremely low resolution of 28 by 28 pixels, but your brain has no trouble recognizing it as a 3. And I want you to take a moment to appreciate how crazy it is that brains can do this so effortlessly. I mean, this, and this are also recognizable as 3s, even though the specific values of each pixel is very different from one image to the next. The particular light-sensitive cells in your eye that are firing when you see this 3 are very different from the ones firing when you see this 3. But something in that crazy smart visual cortex of yours resolves these as representing the same idea. while at the same time recognizing other images as their own distinct ideas. But if I told you, hey, sit down and write for me a program that takes in a grid of 28 by 28 pixels like this and outputs a single number between 0 and 10, telling you what it thinks the digit is, well, the task goes from comically trivial to dauntingly difficult. Unless you've been living under a rock, I think I hardly to motivate the relevance and importance of machine learning neural networks to the present and to the future. But what I want to do here is show you what a neural network actually is, assuming no background, and to help visualize what it's doing. Not as a buzzword, but as a piece of math. My hope is just that you come away feeling like the structure itself is motivating, and to feel like you know what it means when you read or you hear about a neural network, quote-unquote, learning. This video is just going to be devoted to the structure component of that, and the following one is going to tackle learning. What we're going to do is put together a neural network that can learn to recognize handwritten digits. This is a somewhat classic example for introducing the topic, and I'm happy to stick with the status quo here, because at the end of the two videos, I want to point you to a couple good resources where you can learn more, and where you can download the code that does this and play with it on your own computer. There are many, many variants of neural networks, and in recent years there's been sort of a boom in research towards these variants, but in these two introductory videos, you and I are just going to look at the simplest plain vanilla form with no added frills. This is kind of a necessary prerequisite for understanding any of the more powerful modern variants, and trust me, it still has plenty of complexity for us to wrap our minds around. But even in this simplest form, it can learn to recognize handwritten digits, which is a pretty cool thing for a computer to be able to do. And at the same time, you'll see how it does fall short of a couple hopes that we might have for it. As the name suggests, neural networks are inspired by the brain. But let's break that down. What are the neurons, and in what sense are they linked together? Right now, when I say neuron, all I want you to think about is a thing that holds a number, specifically a number between 0 and 1. It's really not more than that. For example, the network starts with a bunch of neurons corresponding to each of the 28 times 28 pixels of the input image, which is 784 neurons in total. Each one of these holds a number that represents the grayscale value of the corresponding pixel, ranging from 0 for black pixels up to 1 for white pixels. This number inside the neuron is called its activation. And the image you might have in mind here is that each neuron is lit up when its activation is a high number. So all of these 784 neurons make up the first layer of our network. Now jumping over to the last layer, this has 10 neurons, each representing one of the digits. The activation in these neurons, again, some number that's between 0 and 1, represents how much the system thinks that a given image corresponds with a given digit. There's also a couple layers in between, called the hidden layers, which for the time being should just be a giant question mark for how on earth this process of recognizing digits is going to be handled. In this network, I chose two hidden layers, each one with 16 neurons, and admittedly, that's kind of an arbitrary choice. To be honest, I chose 2 layers based on how I want to motivate the structure in just a moment, and 16, well, that was just a nice number to fit on the screen. In practice, there is a lot of room for experiment with the specific structure here. The way the network operates, activations in one layer determine the activations of the next layer. And of course, the heart of the network, as an information processing mechanism, comes down to exactly how those activations from one layer bring about activations in the next layer. It's meant to be loosely analogous to how in biological networks of neurons, some groups of neurons firing cause certain others to fire. Now the network I'm showing here has already been trained to recognize digits, and let me show you what I mean by that. It means if you feed in an image, lighting up all 784 neurons of the input layer according to the brightness of each pixel in the image, that pattern of activations causes some very specific pattern in the next layer, which causes some pattern in the one after it, which finally gives some pattern in the output layer. And the brightest neuron of that output layer is the network's choice, so to speak, for what digit this image represents. And before jumping into the math for how one layer influences the next, or how training works, let's just talk about why it's even reasonable to expect a layered structure like this to behave intelligently. What are we expecting here? What is the best hope for what those middle layers might be doing? Well, when you or I recognize digits, we piece together various components. A 9 has a loop up top and a line on the right. An 8 also has a loop up top, but it's paired with another loop down low. A 4 basically breaks down into 3 specific lines and things like that. Now, in a perfect world, we might hope that each neuron in the second to last layer corresponds with one of these components. That anytime you feed in an image with, say, a loop up top, like a 9 or an 8, specific neuron whose activation is going to be close to 1. And I don't mean this specific loop of pixels. The hope would be that any generally loopy pattern towards the top sets off this neuron. That way, going from the third layer to the last one just requires learning which combination of subcomponents corresponds to which digits.
With this introduction, we started with a video because there are many people, they were not there at the time. Let me see how many participants have joined now. No, still 25. Okay, let me start now. It is already, I think, 2:10. Okay, so let's start now. Okay. Let me go back to the where I was coding. Give me 1 second. I was not coding here. I think I was coding this file. I'm not wrong. Over CNN. So by the time I was not online, so it got disconnected. Let me do it again. You people also can reconnect if it is not connected and redo the steps quickly. If it is not connected or the dataset is not there, just check it out. Whether if it is there, I mean, check it is still connected or not. If it's not connected, please reconnect it and check it in the file section whether you still have the dataset with you. For me, this file got recycled, so I have to do it again. It will take just 2 minutes. Yeah, now it's got connected. Let me check the files section. No, I don't have the COVID data. So yeah, I don't have that one. So let me do it quickly. You people also can do it. I think most of you would have got recycled. Just click on this. It should be getting it done. Download done. If you can keep it ready up to the line when up to the portion where we got our data. Sorry. Okay. So after the zipping is done, unzipping is done, where we are again checking, just recapping, we are checking how many number of COVID images we have, how many number of normal images we have, followed by we are using our OpenCV library so that we can view the data with IMRead. We are reading the image file and we are using matplotlib library and the function IMShow so that we can view the image. We are just here taken a sample image. Now we are checking what is the size of each and every shape. That is 300 by 300 and the color is of three colors are there. That is color channel RGB. Followed by what I want to do, this image data, I want to load it in my pandas data frames. For that we are importing pandas and NumPy, and we are trying to read the metadata from the COVID file and we are trying to read the metadata so that we can get the URLs from here. These are the URLs, and you're going to each and every URL and fetching the file and loading it in your data frames. So those are the things going on here, path, getting the path and all. So this has been done for only one of the images as a sample, but then we have defined a function load images, and we are going to call this load images function for both the data. One is my COVID image and another is my normal images, and we are going to check then we are going to do some looping and all. So let me see. So for this COVID image section, what we did, the target variables will be COVID images, that is my input data, and COVID targets. Targets means for the COVID images, the target should be for all the images, it should be equal to 1, correct? Because we said the last time also, I said, just for your recap, we are doing a classification problem in which the input should be labeled. So for every image, you should have classified it as a COVID positive or the COVID negative one. COVID positive means here we are given a target or label as 1, otherwise it is 0. Okay, so yes, length we have checked, it is the same 3000. Similarly, we are loading the images for the normal library. Normal folder, normal images folder, which has around 10,000 images. So that is getting done. And for all of them, we have given the target variable as 0. We've classified them as 0 non-COVID images. Taking some time because it's 10,000. Just for your recap, so that the people who told are not following, they can follow, I feel now. So now we are checking the size of my COVID images frame and my COVID images data and my normal images data. And so what I have to do, we have to now have a consolidated file with both the data and both the targets. So now my consolidated data file will be data, and we have used a function np.r hyphen. It is there in the NumPy library, this r hyphen function that will do a row-wise merge. So here we are doing a row-wise merge of COVID images and the normal images. And we are printing the consolidated data size, followed by, this is actually my x yesterday on, I mean all the 3 days before, we have done something with the x and y, correct? So x was my data and y was something to be predicted, or which is my label. So this is my x, this data will be acting as your x. Now you will have your y, or the target should be the merge of your COVID target and the normal target. So that is done. So we see the targets is an 1 column array basically, rather. So then yeah, so from now I should explain. So anything, so are you people done up to this? Because I know you people did it once back, but I think all of you would have got disconnected from the runtime. So is it done up to this? Can you ping that, or should I wait before I explain the further? Now just little portion is remaining that I have to explain, that how to create the model, followed by how to evaluate the model. That's it. Once it is done, please let me know. Once it is not done, also please let me know. Okay, one participant has replied as done. Okay, fine. So I'll assume it is done for the other people until unless people says it's not done. So I'll start now. So what I have to do now, my data set is ready. So we have to divide the data set in 2 parts. That is my training and testing. So for that, you have to import the library. This thing, like all the last 3 days we are doing, and you should be now pretty familiar with this. That from sklearn.model.selection, we are importing the train test split. So execute this one. Then we have to divide, we are dividing, either you can divide it with 70-30 or 80-20. So right now it is divided as 75-25. Okay, so test size is given as 25%. So it will be divided as 75% as will be my training data set, and 25% will be your testing data set. So let me check it up here. Okay, so my execution is done. If you want to print, if you can try seeing how much is the size of your external test. Okay, now what you should do for my classification now here. Okay, okay, I request everyone to complete up to this train test split so that we can do the model building now. Once it is done, please let me know. It should not take more than 1 minute. Just see that whether you can divide the data in 2 parts, testing and training.
One new book.
Is it done? Can I move? I'll wait for 2 more minutes for everyone to finish up to this and get back to the normal pace. Can I move forward? Is it done up to this? I'll wait for last 2 minutes and then I will proceed. Okay, then what you are supposed to do, you should for filling the same model, you should import TensorFlow, like importing TensorFlow. As we have done before also, when we are doing the ANN artificial neural network, we have used both of this, that TensorFlow and Keras, correct? I hope you remember that. So the same thing we're going to use here. So we are using now from TensorFlow.Keras. We are, and same thing for ANN also. If you remember, we have used the sequential model, correct? So let me import all those. So my import is done. Now what we are supposed to do, we are supposed to create the model. Okay, define the model and followed by we are supposed to compile the model. The steps were same as we have done in our previous discussion on ANNO. So the same thing, whatever we have done, that we have created a model and then we have compiled the model with the current data set, and we have checked the prediction accuracy and the loss with the graph, correct? The same thing we're going to do here. So right now my model is sequential model. So model is equal to sequential. Then what are the layers we're going to, first layer will be my conv2d. Okay, conv2d layer, followed by there will be the layer of max pooling 2d. So this will continue for 3 layers we have given. It is arbitrary, you can make it more as well. Followed by there's a flattened layer. Flattened layer will be for the input. Okay, so this flattening was there in the discussion on ANN as well. If you remember the discussion on ANN, this flattening layer was there for the input also, where we say that the input data should be flattened as a series of 1D array, correct? And followed by we will have a hidden layer and the output layer. Here, this one, last one is my output layer, and we have 2 in between hidden layers. Okay, I'm repeating. Initially, this is all the details about our convolution layer. This is convolution network, rather I should say. And here it is my first layer or the input layer. Sorry, flatten is this one is my input layer. This second and third is my hidden layer, and the last one is the dense layer, that is my output layer. Okay, just to remember, for your remembrance, if you remember, this dense was used when we said that it is densely connected to the previous layer. I means it is receiving the input from the previous layer. So in that ANN also, for the hidden layer and for the output layer, we have used as dense. Okay, now how many? So okay, so now in coming to the what all these parameters are there. So for every parameters, if you can see, there is something called as activation function. Correct. That the INN also we had something called activation function. We said that what is the activation function for any neuron at any point of time of execution. If the value of the neuron is more than the value of the activation function, that time that particular neuron will fired. Will fired means that will pass its value to the next neuron. Correct. So we had multiple types of activation function that I have showed you in the PPT. So for the input layer, for the hidden layer, we are using the ReLU, and the last layer we have used the sigmoid function. Okay, so don't worry if you're getting confused with so many terms. This file will be there with you, and anytime you can just search for this every keyword, and you can get all the details about all this. Okay, so now if the activation this dense activation is sigmoid, so okay, fine. How many number of node is here? So this normally how many number of node will be there in the output layer? There should be 2 nodes. Correct. There should be 2 nodes there, and one will be corresponding to the COVID, and other should be corresponding to the non-COVID. Correct. And if you remember, we have said that your this neural network doesn't give you 0 and 1. The ANN will give you the probability, and we had the Argmax function to check out which probability is my higher, and we had given the output according to that. Okay. So now if giving activation function as a value, then you're supposed to mention it as 2. But if you're giving the activation function as sigmoid, then you can mention it as 1. I mean, the below one level and the upper 1 level. Okay, you can do it that way.
Somebody but
Sorry for the interruption. So this is about the hidden layer and the output layer, and followed by this is the initial convolution layer, which says these are the details of your convolution layer. You can search it out afterwards. The first one is your filters, second one is a filtering window, the third one is the input shape of the image, that is 100 cross 100. If you remember, initially our size of the image was 299 cross 299, and we have done a reshaping of the image as 100 cross 100. So this is my height and width, followed by 3 is a color channel, RGB. Correct? So 100 cross 100 dot this 3. And for this convolution layer, we have used for the activation function as ReLU. It is a mostly used and the most recommended one for the convolution layers. Okay, so this is where we are defining the convolution layer. So don't get confused if there are so many layers are there, so many things are there. So mostly this is going to be standard. You can modify it, you can play around with it and give some other values and check it out how it is modifying and all. Okay, so now once it is done, you click on this and check it out once this model is getting loaded or not. Yes, after we load the model, let me check out what is this model about. So, and give it model.summary, and it is showing you all the summary and it is showing you how it is, all the details about the model. Okay, now you do a model.compiler. Sorry, model.compile. In this model.compile, this step was there in the ANN also, where we had something used. That time also we have used optimizer and Adam and loss was taken as a binary cross entropy. And the metrics, I mean, how you're going to measure that this model is performing properly or not, we're going to use a metrics as accuracy. So let me use it. And after it is done, you can do that. As of now, we have created our model. Okay, our model is ready, but we have not fitted our model with the data. Correct? My model is ready. So as of now, if you remember in the classification, also first thing we load the SVM kernel or the model. Correct? So now my model is ready, and I have defined that what will be the number of usage and all. Okay. So now let me do a model.fit. Okay. So up to this, everyone please do and try clicking on this model.fit and check what happens. So let me try doing the model.fit. So see here, if I'm doing the model.fit, it is giving me an error that your session crashed after all the available is RAM. So what is happening here? So I have opened a lot of notebooks, and also like this RAM will be given to us is as I think 12 GB of RAM will be given to us. And so because I have done so much processing before, so this model.fit, so right now it is not working. It is showing me a crash. So what I have to do in that case, in this crash error, if I get, I have to restart it. So I don't want to waste your time, so that I'll show you here the same data only. 1 second. So it may happen any point of time, this crash, if you are doing a heavy processing there, because there is a huge set of data. 1 second, give me 1 minute time. This is the which one? Because there are so many things I'm executing. COVID X-ray classification. No, okay. So let me go to the previous file. 1 second. I'll show you how it should work if I would not have got the crashing error. Open this one. We go down. So my model building is done. No, this doesn't have the similar things. 1 second. Let me load it. You people, by the way, don't waste your time. You people can try this in your system and see that what is output you are getting. I'll just show you the output properly. 1 second. Just let me do one thing. Let me upload one more name. It will be easier for me to do. I'll upload again. I'm uploading this one. The previous one, which was executing properly. So now, yeah. So now if I go down up to this, I'm done. Yes, the model.summary I have done. Correct. So model.summary has given me this output, and now I try to fit the data. Compile also we have done, and then we tried to fit the data, and while I was trying to fit the data, it had told me that it is going to crash. Correct, because I have used so much of RAM. It is that the runtime RAM, whatever has been provided by Google Colab for me, that got exhausted. Nothing else. There is no error in the code. Okay, once you people are doing, you may not encounter this error. Okay, now what will happen if I try to fit it? Okay, so once you are trying to fit it, if you remember, one thing was my epochs, correct? And we said you have to mention, the major thing you have to mention is my epochs, and also you have to mention what is my validation data set, because that will be used for the feedback loop, correct? The back propagation, and you will work in the next epoch, you will try in the next iteration, you will try to less the loss, make the loss less, or to make the accuracy more, correct? So now, so we are starting with the first epoch, second epoch, whatever number of epoch you have given, it will iterate for that many number of iteration. So we have given it as epoch as 25, so it is iterating for 5 iterations. And after every iteration let you see all the values. So initially, after first iteration, it has started with accuracy. After iteration, the accuracy was 83%, and after every iteration, it has increased. And after the fifth iteration, it has become 94%. If you give more number of iteration, it may increase or may not increase. We discussed about the yes, we discussed about the when to stop when to stop more number of optimization, correct? When to stop more number of epochs. We said there was a term called overfitting, if you remember. We said that beyond a certain level, if we try iterating it so that we get more accuracy in the training data, it may lead to getting the less accuracy in the testing data, correct? We discussed about the overfitting. So whatever I'm telling you, I am assuming that all of you are there in the session when we discussed the ANN, so that you can relate to it, correct? The epochs and this number of iterations, number of epochs, and what do I mean by overfitting? Everything was discussed in that session. So now, if you want to plot the accuracy with the validation accuracy, if you see, this is my training data accuracy. Let me show the graph properly. Let me zoom the graph. So if you see the graph, my yellow line is my testing accuracy and the blue line is my training accuracy. So if you see here, see up to this point, your training accuracy and the testing accuracy is both are increasing. Correct? Where I'm highlighting here, I think you can see. So up to this line, my training and the testing accuracy both are increasing. And after that, if I go on and with the more increasing the more training accuracy, here my training accuracy is increasing, but my testing accuracy is going down. This is what we mean by overfitting. So beyond a certain level, if we try to overfit our model with to optimize the training data set, in that case it may end up in having less accuracy in the testing data. So that is what is happening here. So so this is where basically we should stop. If you see here, this is where we should stop. Similar way, we can plot the reverse, I mean the testing and the training loss also. We can see the training and testing loss also going down here. And here we have, okay, someone is messaging something. I'll come to that. Here it is, here if you can see, this is where is my overfitting. Okay, so this is where we should stop. Okay, so that is it all about it. And so this is your model, and this model you can use for the similar way however we have done. In the similar way, you can give it one image data. Okay, you can make the input as only one image data, and you can check it out whether it is giving you the correct output or not, COVID or non-COVID, as we are doing in all the steps. So now let me see if people can keep on doing it. And some doubt I got. Okay, please tell us about the difference between testing accuracy and the training accuracy. Yes, correct. Sure, sir. So maybe I'll go to the slide of my yes. Mean will it given with respect to some parameters. Parameters means what, sir? I'll explain first what is the training accuracy and what is the testing accuracy. Then I'll check if I did answer your question or not. Okay, so let me just tell it in this way. Overfitting. Again, I'll explain with this only. I think you can see this. Maybe I'll go to the PPT only. I'll open one second. Yeah. Yes, so this was about a discussion on overfitting. So First of all, we should understand what is a training data and what is a testing data. You will have one big data set. That data set, you are going to divide it in two parts. One is my training data, I'm going to say, and another I'm going to say testing data. So normally, whatever examples we have taken, we have said training data is going to be my 80% and the testing data is going to be my 20%. This is not a fixed one. While you are dividing it with a train test split class or train test split function, that time you can mention it as a parameter, correct? But now let us understand why we have to divide it at all, because we are going to build our model on the training data. Okay, we're going to optimize our model on the training data, and whether that model is working properly or not, to validate that one, we're going to test the model on the testing data. I'm repeating it. Training data is the known data for the model. Okay, training data is a known data for the model, and by seeing the mapping between the input to the output on the training data, we are going to make the model. Okay, but remember, once you make the model on the training data, it doesn't mean that the training data only it will be accurate for all the values. Okay, it will give you the best fit. If you remember, let me answer in this way. Let me go to the curve of linear regression. So if I see the curve of linear regression, I hope all of you know the linear regression curve, but anyway, let me explain it again. So if I see my linear regression curve, so this is the graph of linear regression. I hope everyone, all of us, we know about what is a linear regression. Was something wrong? I have clicked it. Yeah. So this is a video of your this is your linear regression curve, simple curve. So if you see what is happening for the linear regression, we are getting a line which is matching to most of the points, correct? But for some or the other points, it is not that much accurate, correct? So on the training data only, so this is the training data on which you have built the model, but on the training data only, we have some errors. All the data, all the points are not falling on the line that you have predicted. Is it correct? So the difference between this actual point and the predicted point will be your training data. It is same across all the classification also. In the classification also, if I have to say, in the classification, when you map, when I decide when there is a say 500 images are there, and we classify the 500 images as say COVID positive, so 400 as COVID positive and 100 as COVID negative, and I train the model, it may happen that out of the 500 images, only 450 images it is classifying correctly. For other 50 images, it is giving you the wrong answer. Okay, so that error or that level of accuracy is called my training accuracy. Okay, that is my training data on the known data only. When I have tried to build the model, it is not matching with the exact point, or it is not matching with the exact level. It's a classification, but that is on my known data. Okay, so that is by training accuracy, and with the higher level of box, I mean one more iteration and hyper tuning the parameter in somewhere or the other, you can make the training accuracy more, because that is your known data on which you are building the model, correct? But the point is this: if you keep on, okay, by the way, so that is how you build your model after seeing and optimizing your model with respect to the training error and the training accuracy. But after that, what you have to do, that model you have created, that should be subjected to the unknown data, correct? That should be subjected to the unknown data, and you should get the prediction properly, correct? So now you're subjecting it to the unknown data, that is my testing data, and on the testing data you are going to check the accuracy. Okay, you're going to evaluate, you apply the model on the testing data, and you see the predicted target or the predicted level and the original level are matching or not. So that is your testing accuracy. Now, what is the issue of overfitting and epochs and all those stuff? It says that when you're building the model, you don't know what's my testing data. You know only my training data, and you will be optimizing only on your training data, correct? So this story says, so initially when your number of epochs or the number of iterations is increasing, your error will go down. Okay, your error is going down for both the training set, the down curve is your training set. So your training set, as long as, because that is known data, if you try to go ahead and give more number of iterations and all, always your training data will have lesser number of errors. But your validation set or the test set can have higher number of errors. So if this is a sweet spot, okay, if you see this line is a sweet spot, or after which if you keep on decreasing and try to decrease the data, your error in the training data set, it may increase in the validation data set, because if here maybe 1 or 2 outlier points are there on based on which you are trying to change your model. So that will not obviously work correctly for the testing data set or the unknown data set, which may not have the outliers. Okay, so this is very important to balance, the strike a balance with the sweet spot. I'll show you 1 or 2 more code where I'll say that, okay, where the number of epochs is not a fixed one. A number of epochs is given as 100, but when you are actually executing, you're not going to actually execute up to the 100 number of epochs. You will see and you will stop when your training accuracy is not changing significantly. How to know where? See, the sweet spot is somewhere where this curve is little bit, the slope is almost constant. Here it is almost a straight line, correct? So there only you should stop. Here the curve is decreasing very fast. So I know here we should optimize. But from here onwards, where your training accuracy is almost constant, you are supposed to stop there only. So now I'm not sure did I answer your question, because you asked me something about the parameters. So sir, 1 minute, let me go to the question again. Ma'am, will it give with respect to some parameters? So can you understood? Okay, fine. Okay, so this conv, okay, there is a Majumdar is asking is, can you please tell about the function, convolution function? Yes. So this is all the data about, just give me 1 second time. Yeah, sorry for the interruption. Yes, I'll explain about it. That is just too much specific about the convolution layer. 1 minute, let me go to that screen. Let me go to the code. 1 second. Zoom out a little bit. Where it was up, I think, no? Oh, this is I think some other code went. This one. So if you see the structure of CNN, with respect to accuracy, I asked 1 second, there is some other question, madam, 1 minute. Okay, is there any value such so that if it reaches that, we can say the system is with respect to accuracy? With respect to accuracy, many times say 95%. So this accuracy, I should say, let me answer this question in my own way. I don't feel that accuracy should be a threshold. You can't bind it out. Maybe we can say 95% is a good, for some system 99% is a good. Depends on how much is it sensitive. I mean, if it is a very critical thing that you are trying to judge, classify, then maybe 99% accuracy you need. 99.99% also. Depends on the sensitivity of the scenario, sensitivity of the situation. It should be, suppose there is, let me say it in this way. So let me take an example. I'm just some random example I'm taking. So suppose if we say that we are doing some operation with a robotic arm. Okay, with a robotic arm, we are trying to do some operation. In that situation, the robotic arm points to the correct cell which is having cancer or which is having the tumor. The accuracy of that segmentation, accuracy of that classification between the disease cell with the other cell should be around 100%, because otherwise the surgery is going to fail if the robotic arm does the surgery on something else. So in that case, that particular system should be very highly accurate. Okay, but if right now whatever systems we are doing, that is just for example in a discussion to make you understand the models and how it works, so that you can learn it further. Okay, so in that case we are not bothering too much about the accuracy. Even if I'm seeing something as 85%, I'm not changing the parameters more as to something else so that it increases more. Okay, so there are 2-3 ways we can do to do with this accuracy. So there is something called ensemble method in your machine learning. So suppose so for the classification we have done it with SVM, correct? The support vector machine, we have done it with logistic regression. There is something else called the decision tree also. So what you can say, suppose you execute one classification model and you see one is my accuracy is coming. What you can do, you can use the merge of all 3 models. That is my ensemble method, and you can see that with that your accuracy should be more. So for ensemble models, there are multiple methods are there. Okay, so see this classification of medical data or anything like this, any deep learning within and all, it's a very huge topic. That can't be finished, or that can only be touched in a 4-day workshop. And also so that's what I'm trying to do, to giving you some idea about what are the things can be there, so that you can explore it further. Okay, so with respect to accuracy, I don't know, I have answered your question or not. So there is no particular threshold as such that, okay, if you have threshold, if you reach this threshold, then you are done. I don't feel there should be something like this. It depends on the scenario. Okay, now coming to the question by Ritvika madam. So she was asking that tell the function of convolution. So here you are, let me go there 1 minute. Where it is? Yeah, here. So the first one, if you see the convolution layer will have something called the filters. Okay, there will be something called a filtering window. I mean, you will be seeing that in the window how many cells are there, how many neurons are there, and you will be activation function will work on that. So these 2 parameters, this is your filters, number of filters, and this is your filtering window. Okay, I'm not explaining these 2 parameters in too much. Then I have to explain the details, the retail theory portion of the convolution neural network. So I'll ask, please, you can explore more on this 2 parameter if you want. Okay, you can explore about this. It's a filter. These both are related. Both the numbers are related to the filters. Okay, this filter, this first number, it should be the multiplication. It should be something with the multiple of 2. It should be something multiple of. If you can keep it as 16, 32, or 64, something like this. So did you all finish the execution, or else I'll do, yeah, so you can continue this one. So after this, we have 2 more medical image segmentation. So for that, I'll be just giving you a demonstration. You can also quickly do this. So entire code I won't be able to explain because of the time that is there. It is already 2:52. So I'll just share the code with you, and I'll just quickly execute it and just explain it as much as possible, so that you can have some idea what we are doing, and later obviously we can explore it further. So let me go here. Okay, chat section, if I'll see if some other question is there. Convolution layers optimization. So there are many more books on deep learning, I should say, or in the internet also we have ample materials are available. You can read the research papers as well if you are doing the research in the deep learning. I mean, on the convolution layer, then you're supposed to understand all this parameters, how this parameters is varying, and where we should, I mean, how many layers should be there, because right now we have said there is 1 input layer, and in between we have 2 hidden layers. Why 2 hidden layers? There can be much more than this, right? And if we have more number of hidden layers, that time your accuracy can be more. So where to balance this threshold and all those things you are supposed to see. So there is no, because right now this field is so much evolving. I mean, there is no standard textbook as such that we are supposed to refer So there are many more textbooks, of course, for learning the basics. But after that, there are so many research papers are available, so many online materials are available, which we can refer to that. Okay, now, so next only 1 hour I have, right? So I'll do one thing. Let me close this COVID section. Just closing all the unnecessary runtime. Okay, this one I can demonstrate, and the lungs. Yeah, so this two I'll demonstrate and finish it off. Just closing the unnecessary things. Give me 1 minute. Because I'm getting confused with which one I'm showing. This is done. COVID-19 data set I have shown you and how to import it from kaggle.com. It is done. Okay, so here I should start. Sorry. Some other question is said. So can I know? Last question is, can CNN be used for image segmentation? Yes, that's what we are doing, no? I mean, okay, image classification I showed. I'll show you something with image segmentation right now. Yes, it can do, sir. Right now, I'll show you one example with which you can do image segmentation. I mean, that example is of lungs segmentation. I mean, you will have we have the CT scan images, right? CT scan images or the X-ray images. So to specifically know out of that big image, which one is actually your lungs. For that, we can have the lung segmentation. So segmentation you can do. I'll show you one example right now with the segmentation. Okay, I'll just demonstrate that one. I won't be able to explain the entire code because of the time limits. I'll just show you the execution. Okay, so that I'll do. And Ritvika, what was the question once again? Can I know or guess different which type of classifier works better on some data set or which type of neural net? Depending on what is the class imbalance is there, whether you have the missing values are there. Depending on that, some classifier works properly, some classifier doesn't work properly. So let me take a very small example if you want, which models. I think I have that one PPT. Just 1 second, I'll just show you. We have discussed two models, right? One was a SVM and one was logistic regression. So now, which classification model I should use if you ask me. So let me just show you. I think 1 second. I think I have made this slide for it. Yeah. So I'm just comparing between two small models. So if you are doing research on it, you will have so many different models that this area is so much evolving, correct? So suppose if for basic classification work, okay, if I have to know that I should go ahead with the logistic regression or SVM, in that case we see the logistic regression cannot handle the outliers very well, but the SVM can handle the outliers very well. Okay, so yeah, so that's what. So I've just given you an example. Yes, each and every model has its own pros and cons. So if you understand the details of the model in a depth, then by looking at the features of the different data, what is the complexity of the data, what is the different dimension of the data is normalized or not, depending on outliers, class imbalance, everything is there or not. So you should be able to come out with, out of hundreds of models, you should be able to get a subset of model which can work on this. Then you further have to optimize on that. So yes, you can get a idea about which models should be used. That's going to be close. Okay, I've closed everything or what? I have closed the entire thing. Yeah. Give me 1 minute. What's that? It's getting loaded. Okay, so I'll share this code link with you. So 2 links I'll share with you. Okay, so this is one of the image X-ray one. Copy link. I'm just pasting this link in the chat section. So this one is a collab link for Google Colab sheet, which will do the X-ray details. I'll show you what it does, and then followed by this one more, which will do the lungs segmentation. So let me go to the chat section. Yes, so these are the 2 collab links of 2 different projects. So I'll start explaining. You can try opening this and just save it in your Google, in your local drive. Then you should be able to do it. Okay, now. So first one, so by the way, these are the codes which are given by one company which is called MD.ai. Okay, medical imaging. MD is for medical imaging.ai. So this company has given this data set along with data set has been downloaded from Kaggle only, but this code and this project has been done by that particular company. So what I have done here is to open this MD.ai annotated. So what is our ultimate goal of this particular project I'm showing you? Okay, so what this project says, it says that given any particular image, okay, so it's a mix of image of chest and abdominal, okay, abdominal X-ray images and the chest X-ray images. So once it says that this is this interface they have given, okay, and I have an option to upload the image, and it should be able to give me it's an abdominal X-ray or it's a chest X-ray. Right now for this is the image we have loaded, it is showing me it's an abdominal X-ray. Okay, so right now if you see here the output is showing you abdominal X-ray. Okay, this abdominal X-ray is highlighted, so it's the abdominal X-ray. If you upload something else, it should be able to give you that it's a chest X-ray. So it is an automatic classification. Just see the X-ray, the different parameters of the X-ray, and they should be able to come out with the automatic algorithm or or an abdominal X-ray image. Okay, so that's what was the project. So to use it or to do it, what you can do here, a very simple thing, all the explanation and all the data link, everything has been given in this sheet by that particular company. Okay, you can open here and you can open it in Google Colab. Okay, that is also fine, same thing. So what you can do first, because it's their project, they have given some custom library, but for you people in a separate project, it's just I'm doing for a short demonstration. You can do it in the way in the previous code we have seen it. I mean, the importing all the libraries starting from CV, pandas, and NumPy, TensorFlow, Keras, and all those things, and read the image with the I am show is used to display the image, and then I am read is used to read the image, and then you have to loop it over all the images. Correct. So the same step I have to follow it for the other projects also. This is they have done it, and they have explained. They have just given us some standard interface to work with. Okay. So I'm just this two project I'll be just demonstrating to show that what are the things can be done. The many more things can be done. It is now left up to you how much you want to do. Okay. So right now this is a MDAI library, but remember this is not any standard library. Okay, this MDAI library is a library of that particular company. Okay, for your projects and all, you won't be able to use this one. Okay, I'm just demonstrating it. Okay, so quickly let me demonstrate. So whatever library they have told, we are taking it. Okay, now connect to that that MDAI project, we have to create one MDAI client. Okay, so for client, what we have to do, if you're executing it along with me, where and where you have to make a change, I'll tell you. So if you see here, MDAI client domain will be public.md.ai, followed by there is something called access token. From where am I supposed to get this access token? This will be this you are supposed to modify. What you can do, you can go to this MDAI annotator. I mean, you go to this md.ai. Okay, I mean, maybe I'll show you here. You click on this link and go to this md.ai. I'll give you some time where you can just see it, how the flow goes on. Okay, so md.ai. So what you can do, you can click on this login and you have the option to click on with to sign in with Google and all. So I have signed it already with Google. Okay, so once I have logged in, so I'm just asking, I'll be logging in with the Google account. Okay, once you have logged in Google account, you click on your profile and go to user settings. Okay, followed by user settings and go to this access tokens. Okay, then you will get a token like this, something token like this. So this is a token I have copied pasted here. Okay, so if you're using any project, if you want to check any of their project, they have some nice projects done. I suggest you to go through those projects and go through those codes, because initially only they have uploaded the data set and all with respect to their library. After that, it is a proper coding. Okay, so I'll suggest everyone to create one. You can do it now also. You can please create one account in your with your Google account or whatever it is, and in md.ai. Okay, and then click on this user settings and this copy paste this token here where you are connecting. Let me go down here. Yeah, first to load the library, and then this domain should be same as public.md.ai, followed by access token. Whatever access token is there, please replace it with whatever AI you are getting. And once you execute it, if it is done properly, then you should be able to get something as successfully authenticated to public.ai. Otherwise, it will not give you. I'll request everyone to please see to that if you can create an account and finish up to this. Let me know up to this if it is done. Whether you are to go, just create an access link account in md.ai so that you can just execute the codes and you can see the outputs on your own. Just create an account on md.ai and copy paste and go to your user profile settings, and there you should be able to get your access token and copy paste here. Let me know once it is done. Is it done? Can I proceed further? So let me see the other messages. Got token, okay. Once you got the token, please replace it there, and then I'll explain it. I'll wait for last 1 minute more for everyone to get the token. Okay, I'm assuming it's done. So let me continue with it. So what you have to do, you can create any project as a client. You can MDI a client, you can create a project and give any name. So as of now, you may not change this name because this name, this is a new project which will be linked to your user account. And if you have created a new user account, it should not clash with anything else. So you can create, you just can click on this. So you'll be getting a project and the project will have the name or reference as P. Okay. So now that particular project, we're going to call it with the name P. Okay, this is just a random project we have created. Now, what we are going to do, that project has the data labels. Okay, that project has the data. Now, what sort of data we have? We have the data of images. One image is called X-ray image. Some set of X-ray images corresponds to the chest, and some set of images will correspond to the abdominal images. Okay, then so what you do, just show this label group. So if I execute this one, what it is showing you, it is showing you that we have two labels. Okay, as we know that this is a classification problem. Classification problem means it is a supervised learning, correct? So supervised learning means for every data we are supposed to have the label. It should be a label data, correct? So we say that in the data file, if the label is this one, then this is my abdominal image, and if the label is L_Z8 and this one, then the label, then it is a chest image. Okay, so let me execute it. Yeah, okay, I would have executed it. Okay, now what we are supposed to do, as it's a categorical data, as if you remember, we say that we're not supposed to work with the categorical field, correct? Now it's a string data with this abdominal and this chest and this ID, whatever it is, everything is my this is nothing but my string data or the object data type, correct? So what you have to do, we have, for any kind of categorical data, you are supposed to convert it or enumerate it with the 0, 1 or whatever it is. You have to make it as an integer. So the same thing we are doing it here. We are doing it so that for this level we are mapping it to 0, and for this level we are mapping it to 1. Okay, so that we can classify with respect to the numerical integers. So this steps we have done it before also with some other data set. correct? So this data, this project is doing exactly the same thing. First, it is checking that how many, what are the levels I have in the target or in the output. We have two levels. We have one is abdomen, and another is my chest. And now it is saying that instead of working with the name as abdomen and chest, let me work with 0 and 1 because it's a categorical data, correct? So let me work with 0 and 1. So after you are done, so let me execute this one. So it is showing you this level as 0 and this level as 1. So dictionary is showing you my mapping is done for the target output level. Okay. Now what I have to do, I have to create the training and testing data set as we do always. So now first let me see the data set. What are the data set I have? So that is true, it is done with p.show dataset. Remember this show dataset and all these are not standard Python commands. Okay, these commands are based on the project that they have created and it is their custom commands. Okay, so you can in your project you won't be able to execute this command, but the steps will be same. You can give just a view command or show command. Yes, as we are doing it in all the Python projects as of now. After we have the data, we are supposed to see the data. If it is image data, then we are supposed to do it with the IM show and all those, correct? So let me see that how many data sets I have. Okay, it will not show you the files as such. It will show you what are the data sets I have or what are the folders I have. Maybe I can say it in this way. So it is showing me that I have 3 data sets with me. I have 3 data folders with me, I should say in that way. So one is my training data set, as the testing data set. I mean, after building the training, what I'm going to test. Another is the last one, that is a validation data set. Okay, training, validation, and the testing data set. Training, validation, and testing data set. If you remember, for any kind of ANN, CNN, we do that right? That we train it with the training data, then do the validation with the validation set, and then we subject the model to the testing data set. So now you have to, what we have to do. So this is the level, or with this train has this train data set has my training data, correct? Now to work it, I have to do some pre-processing. We have to prepare the data so that basically the pre-processing has to be done, correct? So the pre-processing, they have not given any details of what are the pre-processing they are doing for this training or testing. So they just have given it as the command as prepare. Now the details of this prepare command is not given, but I hope you can understand that what are the pre-processing we have to do. Maybe we have to remove the outliers, do some normalization and all those stuff. So this, after this preparation, is a data pre-processing basically. Okay, so they are doing the pre-processing on the testing training data set and the validation data set. So if I yes, it is showing that how many images I have. If you execute this, so you will get this output that we have in our data. We have the 65 images in the training data set, and the validation has 10 data set. Okay, 10 images. Validation folder, validation subsection has 10 images, whereas the training has been done on 65 data set, 65 data images, I should say. Now, if you want to display a few images, for that you can, they have given some function as visualized or display images. But for this, in our project, what are the functions we should use? We should use a function. You should read the, you can import the file OpenCV2, followed by you can use the function imread to read the image, and followed by to display it, you can use the imshow. Okay, so here let me see it how the images are looking like. Be executed. Okay, so it is showing me some images of abdominal image and some images of X-ray. Yes, I think this is my X-ray image. By looking at it, we should be able to understand this is my X-ray image, and this one is my abdominal image. So now my job is that out of a bunch of these images, I should be able to classify them, and I should be able to see that which one is my chest X-ray image and which one is my which one is my abdominal image. So now what we have to do, we have to use same thing, the TensorFlow and the Keras library for doing the classification. So we are using the TensorFlow. So importing the TensorFlow as TF, followed by Keras. So after it is imported, we are now trying to build the parameters. Okay, we are trying to do the modeling, and as you can see, the modeling parameters are almost the same: image, height, and width. That's what, if you remember that just now, whatever modeling we have done, there also we had a parameter of input size, correct? So this is same as your input size, image, height, and width. Okay, followed by, we are saying, just give me 1 second time. Then we have, sorry for the interruption. So first two are image size, okay, followed by we have epochs. So if you see here, epochs is given as 100. Can you see it is quite huge? It means that I'm saying that you go ahead with do the 100 iteration, okay, and then the parameters are there, the channels, classes, and all. So let me see if I want to do this modeling. So let me execute this one. So right now I'm just not executing, I'm just defining the model, okay. I have not executed the model.fit. Model.fit means when you are actually trying to fit the model in our own data set. Right now we are just setting the parameters of the model. Then we are here, we are compiling the model with the other parameters, where we are saying that what should be my activation. Here, instead of ReLU, the activation function they have used as softmax, and the loss function has been used as categorical underscore cross entropy, and the optimizer here also, the optimizer has been used as Adam. That is what we are using from beginning, and as a matrix it is used as accuracy. So this function is nothing but your compile stage, okay. The first one is your model building, and then we are here right now, it is my compilation stage, okay. All these stages we have seen in all the other codes also, okay. So now let me execute this one. So right now my model is ready with all the loss function and the accuracy metric, all the other parameters are set. Now what I have to do, I have to use this particular model to fit in our training data set, and I have given the epoch as quite high. It is written as 100. So let me see what happens when you try to execute it. So this is all my model.summary. If you print, all this will come. Now let me just to load the image, visualize once. We go down and to the actual step where you were fitting it. Yeah. So this is your generating training and testing data set. The training data set, in the training data set, you are dividing the training data set with the training and the validation part. Here, if we go down, yeah, here we have started the fitting, actual fitting, model.fit. If you remember, we had this one, history equal to model.fit. Yeah, so this is a function we have used it, okay. But they have given some other functions and all. You don't require those functions if you are doing it in your project. You're supposed to use this model.fit, okay. So now, so this model.fit is working, and let me see where it actually stops. I have told it we have given as epoch is equal to 100, correct? Right now we are at the epoch 2. So I'd request everyone to check it out whether they are getting this output or not, and let this function finish. Let us see that where it stops, and then only you will be able to understand, I think, where we should stop. Let it execute. I request everyone to please keep doing up to this, and just start this one. It's model.fit. So remember that as a standard, when you are doing any new project on this, as a standard way, what we are supposed to do, we are supposed to do the data pre-processing. You're supposed to do the EDE, or the exploratory data analysis, and the data visualization to get some insight on it. Followed by, you're supposed to do the outlier removal and remove the data imbalance if it is there. You're supposed to encode the categorical column to the numerical ones, correct? All these things should be done in the pre-processing state. Followed by, we should like separate the training data set with the testing data set, followed by you're supposed to do the modeling and all, okay. So this is as a generic one, as generic guidelines, and all the projects are following that only. go down. Please do it along with me. We're at epoch 6, 7. It is going on. So by the time, if you have any other doubts, please ping it in the chat section. Chat section has some other comments I did not see only. Okay, Cola file link I should share. Sorry, I did not see it. Extremely sorry. I'll share it. So the previously only I've shared. I'm just copying pasting the same link here. Request everyone to please create a link in the md.ai and check it off. So the first link I have shared, that is belonging to whatever I'm doing now, that is given an extra classified, it's a chest x-ray or it's a abdominal x-ray image. And the second one that I'll be showing the demonstration now, that will be the lung segmentation. Given an image, x-ray image or the CT scan image, do the segmentation. One second, why it is not allowing me to share? Give me 1 minute. Lungs extraction. Yes, sir, I've shared both the links. Both the links are shared. Right now, let's see that where are we. All of you, please keep it doing. In 5 minutes time, I'm giving for everyone to do it. So as of now, also it is continue to doing it. Yes, now I think it will stop. Yeah, great. So please see this. Once again, it will stop now. It will stop here only. So it is saying, if you can see, validation loss did not improve. You can keep on doing. I'll tell you. After next 5 minutes, you can keep on doing this one. Yeah. So I request everyone please to note here what it is happening here. And this is very important for you to understand also, because that also I got a question that how many number of epochs I should give and how should I decide this one. Correct. So here, if you remember in the model, we have given the number of epochs as 100, which is very huge. Correct. Now, but what is happening when you are actually executing it? After every iteration, it is checking the field as value loss. What is the validation loss is happening? Validation loss is validation loss. So it is every time it is checking that whether my validation loss is changing or not. It is, validation loss is changing means your accuracy will also change. Same. Okay. If you are every time you are checking the validation loss is getting less or not. So yes, initially it was reducing, but now 1 second. Yeah. So now see after my 13th epoch, it started to say that this validation loss did not improve. Initially, the validation loss was improving. Validation loss improving means the validation loss was getting reduced. Okay. Now here, if you see here, it is telling that validation losses not getting improved, correct, in this epoch 11. Now if you go here up to 12 also, it is telling my validation loss is not improving. Here also continuously 3 iterations it is checking, and it is checking that validation loss is not improving at all. And so at the next one it is telling you that I have to stop. If you see here the epoch 14, it is saying that early stopping. Okay, so at it will not, so remember this neural network will not at a particular level, if it sees that the validation loss is not decreasing, it will not stop. It will check it for continuous 3-4 iterations. Still, if it says that my curve is flattened, my whatever my accuracy reduces, the loss curve was there, that is flattened, then it will stop that one. Okay, so it will stop. So even if we have seen that my the epochs should be, maximum number of epoch can go up to 100. It is reducing when it sees that it should stop. that request you to please keep doing up to this and see whether you are getting this result or not. Is it done? So let me see the chat section. Early stopping happened at epoch. Okay, fine. For me, it has happened. Actually, after 11th only, it is saying it is the validation is not, validation losses did not improve. But for me, I have got it is stopping up to epoch 14. That's fine. After the status, after 11th only, after 11th, epoch count is not improving much. Correct. So if you are doing any coding, you should always check this when this validation, validation loss curve is getting flattened, when it is not reducing. That is a time you should check it for 1 or 2 constant iteration. If it is not changing more, then you are supposed to stop the iteration. In my case, one second. In my case, validation loss did not improve from epoch 9. Yeah, I think because so that's what I'm wondering, how come? Because we are all using the same data set now. So yeah. One thing may have happened because we have done the training and data set. Yeah, I think why this randomness is actually coming. We have divided it in no, train and data set also we have not divided. No, train and data set already we have got it from them directly. It is not a random division. Not sure why this randomness is coming because I think in the validation data set, yeah, I think there we have divided it randomly. Somewhere it is coming only because early stopping is at 12th. Yeah, I'm getting at 14th. I have to check it out. Somewhere we have done some random. They would have given some parameter with rand, and because of the randomness, it is getting changed. Until and unless if you use the yesterday and all, we are using the function as, if you remember, with random, when there is something random, we are doing something with a random seeding, correct? So that whenever we are using that function with the same seed value, everyone will get the same result. Okay, but I think here some random would have been used in some of the other function. We don't know, right, how they have done it, because many times we're using some function directly, which is we don't have the code for it. So I don't know what has been changed here. So I feel that there is somewhere or the other some rand function would have been used so that we are getting the different outputs, and that can happen at any point of time. Okay, so yeah, we are done with it. So for me, it is stopping at 9th. So now if you see here, so yeah, so now you can plot it as this plotting we have done before also, right? We are supposed to plot the graph of your validation accuracy and the training accuracy. So if you, and the loss as well. So if you plot it here, so you will see this kind of a graph, something getting plotted. So right now your training accuracy, And the validation accuracy, if you see here at this point, it is getting stopped, correct? Yeah. So now if you go down here, so this is up to when you are building your model with respect to your training and the validation set, correct? So, and now what you have to do, you have to test it with the unknown data set. That is my testing data set, correct? So for that, the same the TensorFlow has been used. So right now, let me just clarify one thing. Yesterday on whatever we have done, we had only one big data set. In that big data set, initially we have divided it in two parts. One is my training, that went into the 80%, and there was a testing, which was my 20%. And then when we build the model, say NN, that time in that code, we have said that among the 80% of the data which has gone to the training, reserve 10% for the validation, which will come for the back propagation and all those stuff, correct? But here in this code, they have three separate folders, three separate data set. One is my training, one is my testing, and one is my validation. Okay, so both training and the validation is used when you are doing the modeling and iterating it. I mean, you are having multiple epochs and you are checking with the validation data whether you are decreasing the error and all those stuff, correct? So, and now the unknown data is my testing data. So now we have to check it, what is accuracy with respect to the testing data. Executing it. Just clearing the previous session and all. You're loading the model. You are loading your test data set, and which is given by the name test. And then here you are reading all those images. Okay, here you are reading all those images. It's the same as when you are reading all those images, plotting it. Now see it, what is output of this stage. You're applying your algorithm on the testing one. Yeah. So it will give you this kind of situation where it will say that this image has been rated as a chest X-ray with a probability of 1. Probability 1 means 100% probability basically. So this image, it is saying with 100% confidence that it's one chest X-ray. Where at down, whichever is coming, whichever this down, which this X-ray has been classified as abdominal image with a 100% probability. So coming to the other areas, and also it is like something, just a color image of it has been given. Okay, so these two are the cases where it is very clear cut. It's a test image and it's abdominal image, but you can have a mix of it and all. In that case, the probability will be not 1. It will be a little bit less, and as we know that this network will not give you as such. It will give you probability ratios, and whichever is the probability is higher, that we should use as my output. So with the RBanks function and all, yesterday last day we have done it, if you remember. The message is there. Let me check. Okay, so early stopping is someone is getting at 12. Okay, so how come I think it's Vika, Ajay said everyone is getting it at epoch 12. I'm only getting at 14. Maybe I have to restart it again. Let's see. Okay, doesn't matter. But I think everyone would have understood the idea of what do I mean by the overfitting and when we should stop. When we should stop the iterating and iterating again and again over the same data. Okay, I hope that much is clear for all of you. Now, so how to decide the number of epochs? You do not have to manually write a number. It depends on where your validation loss is not decreasing anymore. So is it done? All of you have got this last output. Everyone, all of you have finished this execution. This is the finishing where you're classifying it. Done, everyone. Then I can just show you the demonstration of lung segmentation. Okay, Ajay has said has told it is done. I'll wait for 1 more minute for other people. We can wait for 2-3 minutes more. Let me know once it is done. There is a question in the chat section. Let me check. Any method to avoid the problem of high RAM utilization? Yeah, actually, in that case, actually, in that file, it was actually already used. That converting the size of the images was reduced. If you remember, the size of the image was initially 256 to 50 to 299 299. The image size was reduced. Okay, so like this, some optimizations you can do. Okay, now one more question. 1 second. Ritvika madam is asking that, ma'am, can you say about prediction of chest width? Which one I should say? Prediction of chest width probably 999. Where it is? Chest probability of this one. If you see here, I think you're asking about this one. See, the output is coming here. It is saying that it is predicted with as a chest image with a probability of 1. I mean, 1 is nearby 100% actually. I think you're asking about this one or something else. Let me know if I not answered your question. If I would have understood your question wrongly. Both of them, yeah. So this one. So if this is an image, it is coming as my this, because this is a very clear cut image of chest, correct? Chest X-ray. So it is classified with the probability of 100%. 100% guarantee it is telling you. For this one also, it is an abdominal image. Can you see this is a very clear cut abdomen, but it will not be the case always. That the situation can be blurred also. So let me just search online. Blurred X-ray. 1 second. So see, sometimes your X-ray image will not be that clear. X-ray image can be this much blurred also. Okay, so or it is somewhere in the X-ray image of chest. Maybe sometimes a little bit of the abdomen has also would have come. In that case, it would not have classified it with the 100% accuracy. In that case, it would have been less. Okay, now let me see. Okay, now please let me end it and let me go to the last one. That is a segmentation example. I'm closing this one. Okay, this is a lungs X-ray segmentation. Okay, so what we want to do, let me go down and show you what is that we're trying to do here. So given we have lungs X-rays, where your X-ray plate will look something like this, correct? This is your X-ray plate. Now we want to have something with a X-ray lung segmentation where the exact portion of lungs should be identified. Okay, so for that we have this kind of image where you're actually identifying where is your lung. So if you see here, we know that this is the one lungs portion, this is one lungs portion. If you see the second image, you are seeing that where is your image, actually your segmentation is there. Okay, so now for that we have something with the image masking and all. Okay, just let me quickly just demonstrate it. Okay, so first, as we have done before also, please import the libraries. search more about what is this lung segmentation, and anyway the code file is given to you, so you can explore it more. So, and then you can create one MDIA client, so that in your previous file you have copied pasted one access token, no? So please copy paste the same thing here. One second. Yeah, go here and the domain will be same only, and access token, you please copy paste the access token that you have got from your user account in md.ai, or you can use the you copy paste from your last page as well. Same thing, no change. And then it will go ahead with the same way. First you should create one project. So once a project has been created for me, we should see that what are the label groups I have. So now here everything is lungs only. Okay, so there is, we are trying to do a segmentation in the lungs image. So there is nothing like previously, if you remember, we had two labels, correct? One was my lungs and that was my abdominal. Here everything is lungs. Okay, but there are two segments. So now what we are going to do, so we are going to, instead of working with the name lung, we know that we have to work with a categorical variable. We have to give a numerical encoding for it. So it is encoded as 1. Followed by, we are checking with our training and the validation data set. And this prepare is my pre-processing of the data set. And let me check that how many images I have. This length of images IDs will give you. So right now we say that it's a pretty small image data set. It has only 138 image. And then if you want to see that what are the images are there, so how the images are looking like, you can use a visualization. And if you see, you can see the different images are there in which you're supposed to pinpoint or segment actually your lungs. Then here you are preparing the data set for that, and you're creating the model for that. You are supposed to load your keras and the TensorFlow. And we are using the NumPy CV2 as OpenCV, and then your matplotlib.pyplot for your plotting work. Followed by the same thing goes on that you are supposed to load the images. You are supposed to define a function load images that will actually load the images, correct? So now this load image function should be called for all the lungs dataset. Okay, and you're creating the images and the mask also for this. And followed by, it's a long coding, is already, time is already, I think, already up. I'll just execute it and go to the output and show you. Okay, so something like this you should be able to, after that, if you can do the modeling creation, and also here also I should be able to show you the epoch situation. And here if you see the, okay, something is not coming properly. I think some of the other steps I would not have done before. Once again, what is the error it is throwing me? Import, not which one? Some importing I would not have executed. I'm doing it fast now. Something I would not have executed. 1 second. Let me go up. Anyway, not a problem. I think you are getting the flavor. Something I would have missed it here. Execution. You can try doing it on your own slowly. I think some import would not have happened. That's why it is getting easier. Anyway, doesn't matter. I think you got the point. Once you execute it here, if I go down, training the model, I'll go down and show you the situation where we have executed it. Here we are using this. This is what I wanted to show you. Here I've tried to here they have tried to model.fit, okay, where you are actually doing the modeling, and here epochs is given as 10. Okay, the suggested epoch is given as 10. Let me see where it is stopping. So initially the validation loss is improving. Correct. Initially the validation loss is improving, but if I go down. Yeah, so can you see here also that even if we have said the number of epochs, maximum number of epochs is 10, it is stopping here, hardly stopping. If you see, it is stopping at epoch number 80 only. I think it is visible. It is stopping at epoch number 8 only. So remember, this is how, like whenever the validation loss is not decreasing anymore, you're supposed to stop your iteration. Okay? Your model will stop your iteration. So in that, after that, you can use your matplotlib, the pyplot library, to plot your validation loss, accuracy, and all those stuff, followed by your prediction. Okay, so this is where it ends. So I think it is a lot of things I have spoken. You can take your 5 minutes time to execute it and then check whether you are getting it or not. So the basic idea should be, you should be able to grasp. The basic idea is same across all the projects, like training, testing, checking for the overfitting, checking for the pre-processing, exploratory data analysis, where you are viewing the image or viewing the data. Maybe you're doing, if it is just a normal data, you would have done some graph visualization to see the outliers and all those stuff. Yeah. So yeah, so please take 5 minutes of time. It is, what is the time? Let me check it out. It is 3:51. Last 9 minutes we have. Please take your time to check it out. So in the last 4 days, whichever hands-on session I have handled, with my limited capacity, I have tried to give you the glimpse of this entire ocean where the deep learning or the machine learning can be applied to the area of medical data and medical data analysis, starting from the where we can apply the simple medical machine learning models, followed by where we can apply the artificial neural network, followed by where we can apply the CNN. And also I've tried to show you that how we can do some disaster modeling with the data visualization, and how we can use a Facebook profit model, FV profit. Yesterday we did that one, FV profit model, to forecast that whether we are going to get this disease back again or not. Any kind of data where you need the time series analysis, that time you are supposed to use this FV profit. So yeah, so that's it from my side. So yeah, so I'd like to thank everyone for joining. Yeah, someone is asking a question once again. Go down. Thanks a lot for your input. Okay, sir. Thanks for it. Nano hands-on, it's in online mode. How much ever possible for me to do, I tried to do my level best. Hope you will be able to get something out of it, and then you can do your own projects, and as much projects you do, you'll be able to learn. Okay, someone is getting some error. Okay, keras.unit.init is import. Yes, I think, you know, what would have happened, maybe I think while doing this, I'll just check it out. Maybe I would have, when I'm sharing this Google Colab link, I would have shared something wrongly with you. So what you can do, madam, this coding is given here only. I have shared this Colab link. No, maybe I would have shared, copied pasted something wrongly would have done. So here you see, if you go here, from there only they have given all this. So as of now I have shown you these two projects. They have the link for this pneumonia detection also. You can directly open it here. Okay, this lungs extra semantic segmentation using UNets. You open this in Colab and execute. Maybe whatever something I would not have imported and all. That is why it is showing this error. Okay, please open it directly from here. This entire code has come from here only. Okay, please open this one. And these are the two processes by doing. You just open it in your Google Colab and try doing the pneumonia classification. And this one is this is a very, it is RSNA. It's a very huge data set. It is almost 3.7 GB. If I'm not wrong, this RSNA, this data set, no, it's a 3.7 GB. This is a huge data set. So you can use it. Yeah. So now some other doubts over there. CNN can customize. Yes. In the CNN, you have a lot of parameters. When you are doing the modeling, you have a lot of parameters where you can choose your whichever activation function you want. You have activation function as ReLU. There is ReLU, ReLU. We have the TANH, we have the sigmoid. There are many more activation functions are there. Now, which activation function should be used for which particular scenario? That you have to see. That was not possible for me to cover in this 4 day of sessions. So, but yes, all these parameters you should be able to change, and you can customize it according to what you want to do and how many number of layers. Yes. Okay, is there any option for our RAM issue? So RAM issue, Google Colab provides you with a free limit of 12 GB. So if someone wants more, then they can go for either you use go work with your Jupyter Notebook and Anaconda, okay, and use your local server, or else you can that will be paid access actually. So you can go to Google Colab. If I go here, there's something Google Colab that was it was suggesting when it was crashing. Google Colab Pro. If I go here, so 1 second. Yeah, so right now we are in the free of cost is the current plan. So this Google Colab Pro will have more RAM space. If you see here that it's a faster, more memory and all. So if you work with Colab and if you want more space, then you are supposed to go for a paid access. In the segmentation output, can we also measure the length? Yes, of course, because the segmentation is how you are segmenting. All the details we have skipped and shown you the output. You are segmenting it with the mask and the length and all those things. In short, yes, it can be done. All the parameters should be extractable. So I think that's it from my side. So this is a huge ocean. I mean, there can be many more things that you can do. And here there are, because I think there are many more people who are doing the research on this deep learning. So in that case, the model can be improvised more. So it's not that we have to use only the model that is given to us. We can improvise the model as well. That's what is a research better. Whichever you see that which one is not there, whichever is not present in that model, that's what we should do as an improvisation maybe. Thanks a lot for everyone to join it. It has been a wonderful session for me. Yeah, thanks. Thank you, madam.
Thank you. 1 second, ma'am.
Yes. Can I stop sharing?
Yes, ma'am. Sure. Thank you, ma'am. Thank you, ma'am, for your time and lecture. The best and the beautiful things in the world cannot be seen or even touched. They must be felt by heart. Thank you is one such prayer among them. I thank Professor Antara Roy Chaudhary for enlightening presentation on breast cancer classification using machine learning, data visualization with breast cancer data, and machine learning for COVID-19 using Python, Kaggle, COVID-19 radiography database, and all the steps for the download session for the Kaggle dataset. Thank you so much, ma'am. And at the last, for the participants, I remain most grateful for the rapt attention with which you sat through this lecture. I'm confident that you have learned something from it. Thank you very much.
Thank you, ma'am. Thanks a lot, everyone.